It looks that we are live. Yes, we are live. Hello, everybody, and welcome back to another Hangout. So, yeah, this is a typical one. This will be probably a typical one of my Hangouts. I have a guest with me who actually didn't want her name published beforehand, but I guess it's fine to say it now. Hello, Betty.
Hello.
So, can you maybe tell us a little bit about yourself? So, you're a flat earther, right?
Yes, I am.
Okay.
Since 2014.
Since 2014. Okay.
Yes.
Is there any particular flat Earth model or map you're buying into? Are you buying into the AE map or the square map that was proposed by Part-Time Vegan, for example, or by Multi-TomTom?
No, I'm not into a particular map for that.
Okay. So, what is, like, if you had one single argument to bring forth for the flat Earth, like one where you would have to put your reputation on, what would that be?
Oh my God.
like what's your best argument for the flat Earth? That's what I'm actually curious about.
Well, the best argument I think is that everything else presented to me that it should be a ball, a spinning ball, is for me out of the question. So that makes it by default a flat Earth.
So
that's my position.
Okay, but you do understand that even if this were true, even if the Earth would be proven right now not to be a ball, this wouldn't automatically prove a flat Earth, right? There would be still different possibilities.
Could be any shape, yes.
Okay, so you're not necessarily thinking that the Earth is flat, you're just thinking that it's not spherical.
Exactly.
Okay, great. So what I would propose now is let's just take a look at my personal argument to show why the Earth is a sphere. Is that fine for you, or do you want to present something first?
Well, I think it's best if I go first because you wanted me to answer a couple of questions you had initially.
Yeah, we could do that, but you said you would have something you would like to talk about as well.
Exactly.
So since you're the guest, I would like you to go first, if that's fine.
Yes, that's fine. Well, first of all, thank you for inviting me on your Hangout.
Sure.
And I want to do a shout out to a couple of guys that I met before, like Rich Redrick, for example. Shout out to him. I hope he's getting better because I've read that he had an accident with his car. And I want to do a shout out to George Natyuk. I have some interactions on some posts with him. And also to Steve McRae, who introduced me to G+. For the first time, and later on also on Hangouts where he discussed my posts. So that was also very cute to see. And I want to say hello to the audience, of course, and I hope they will not lose any brain cells over me, but you want them already, so I don't think that will be a problem. If they want to listen, they can listen. If they don't, they can just leave. So and I wanted to answer your questions because you wanted to know a couple of things about the night sky. I will literally say what you posted to me. The night sky, 2 celestial points. You wanted to know about that. The movement of the stars and the planets, the moons. The direct curvature observations, for example, Lake Pontchartrain, boats going over the horizon. The fact that we know how gravity works, plate tectonics, not working on a flat plane. Those were the questions initially that you posted to me on the Google chats. So I wanted to have a go at these.
So why don't we start with the most simplest one, the night sky? It's the easiest one to check, I guess. Of these.
But I want to lay down my foundation where I'm coming from first.
Okay,
so if you will bear with me, and I will go into that first. So I will try to answer your questions, and I have one single question for you, and that's, what's the scientific evidence for your spinning ball religion? That's the only thing that I have, and I hope that you will have an answer for me.
Yes, sure. So do you want to present your stuff first, why you think the other points that I brought up aren't valid, or do you want me to answer your question first? What is your
No, that's okay. I will go first into a little bit of the presentation, or my viewpoint, my perspective on things. I bring up the word perspective on purpose because that was a lot of jokes were made about it, and people wanted to know what it is and what is my perspective. Why did I use that word? And well, I have now it's a little presentation on also on perspective and what it is and what I use it for, and a little bit of my worldview, where I'm coming from, so that you know where my foundation lies, what my presuppositions are, because everybody has them, not only me, but everybody has a presupposition. You have no God, and I have a creator, a God, and that's what I want to explain.
Well, but just before you continue, having no God as a presupposition is, per definition, not having a presupposition, right?
That's a presupposition because you are having the foundation that you have no God. That's your start point.
That's not what I'm saying. What I'm saying is there's not sufficient evidence to make or to be sure that one exists.
That's your point of view.
One is a negation and one is not a confirmation. There's a difference in the meaning of those. But whatever, we can talk about that later.
Yes, okay. So what's my definition for perspective? Well, you have 4 definitions that I found. And that's first one is a particular way of considering something. The second is to think about the situation or a problem in a wise and reasonable way. And the third definition is to compare something to other things so that it can be accurately and fairly judged. And you have also perspective in art. The way that objects appear smaller when they are further away, and the way parallel lines appear to meet each other in a point in the distance. So if I use the word perspective, it can mean either of these 4 things. And everybody knows these things. It is the point of view, the way you look at things. So, and I want to see, to make sure that everybody knows what my worldview is and what my perspective is in this world and on this world. So I call myself a sci-flag, and that's it means a Christian young flat Earth creationist. And so I'm a Christian. I rather call myself a follower of Christ or a disciple of Christ, because everybody calls himself Christian nowadays, and it's not all the same. We have many denominations, and I think that being a disciple of Christ is more precise. And I believe that the earth is as old as the Bible tells us it is, and that the earth is flat and motionless, and that God created the earth and all the sun and nature, moon, stars, everything. And he also made laws, the laws of physics, logic, and love. So my question...
Sorry, what was the last one? The laws of physics, logic, and what was the third one? Love, okay.
Yes. So my starting point is love. That's what I think is the most important in the world. And I don't know if you... What's your thing? What do you think is most important in life?
How is that relevant to the shape of the planet?
That doesn't matter. That it's just to make sure what is our key point. Where are we starting from?
What do you mean by where are we starting from?
Well, I want to make a presupposition. So my starting point is love, and love is, in fact, the creator. Love is an entity. Love is God. God is love.
Okay, so you have a presupposition that some sort of entity exists which is identical to love.
Yes.
Okay, that is weird.
And why is that?
Well, when we're talking about presuppositions, mainly dealing with what we think about reality, there's actually 3 presuppositions that everybody must make. And that is first, that the universe actually exists. That second of all, we can learn something about it, right? Mm-hmm. And that when you actually analyze or try to model reality, we have to consider that, or we must presuppose that models that have the ability to predict stuff are better than those without the ability to predict stuff. So when you're talking about presuppositions, those are the only 3 that I must have to actually do scientific work in any way.
Mm-hmm. Okay.
Does it make sense for you?
Yes and no. I know that's your starting point. My starting point is this. Love is that everything that binds together.
Well, when you say a quote, my starting point is, you're already presupposing that you exist. So your first presupposition there is that the universe in some way exists.
Yes.
Okay, so we share that one apparently.
Yes. Yes, we do.
Okay.
But then there is something that holds us together. There is, and love has many meanings. Like the word perspective, love is also very. It's a definition can't be given for love. It holds so many things, and love is the beginning point for me because it holds things together, and it has truth in it. So I will continue, and I will say what the laws of love is. What do you think that the laws of love are?
No idea, honestly. I don't think I could make or even define laws for that, and that's
Okay.
actually a problem. First of all, how is this relevant? How is it relevant to the shape of the
I will
planet?
come to that.
This is scientific stuff that has nothing to do with feelings whatsoever. This is
I will come
a
to
matter
that.
of hard fact.
You agreed with me that we could talk about this. I would say that I would make my point clear to you.
Yeah,
So
sure.
So if you bear with me a little bit, and I will
Okay.
go through this like this, and then we can talk about the shape of the Earth, because that's what you want to talk about, and I want to talk about that too. So, but I want you to know where I'm coming from. So later on, then you will know why I react and respond the way I do sometimes. That's
Okay.
what I want you to know. That's the reason why I want to go through this. So the laws of love are the 10 commandments from the Bible. Do you know the 10 commandments from the Bible?
Which set? There are two sets. One in Exodus 20 and one in Exodus 34,
Well,
and they're completely different.
I will read them to you then.
Yeah, and I'm asking you which set, because I think I know both of them.
Well, then, we'll state them then.
Well, in the first one, the first ones are actually the standard 10 commandments that you know, like, first of all, don't have any gods beside me. Second of all, don't make graven images. Third of all, is third, don't honor your parents. 5, don't kill. Don't steal. Don't desire your neighbor's wife, and so on.
Yes. So I will call them all out. You shall not make idols. You shall not take the name of your Lord your God in vain.
Yes.
Remember the Sabbath day. Honor your father and your mother. You shall not murder. You shall not commit adultery. You shall not steal. You shall not bear false witness against your neighbor, and you shall not covet.
All right. Do you know how the list actually continues? What is in Exodus 21, for example? Because the ones you are citing are in Exodus 20, and I'm actually curious if you know what is in Exodus 21. Because if you actually read the script, the list doesn't stop at 10. It continues through Exodus 21, 22, and 23.
These are the ones that I want to talk about. These are for me the laws of love.
But those aren't referred to as the 10 commandments. That's actually the set in Exodus 34.
That's okay. That's okay. But these are the things that I live by.
Okay.
Yes. So that these are my laws of love that I live by. And love has many attributes, and love is not able to lie. So love is truthful or true. So truth and love go together. And if you are untruthful, then the relationship is broken, corrupted. Can you agree on that?
More or less, yeah.
Yeah.
It's just a weird concept for me to start with this. Mm-hmm. I'm trying.
I understand.
To think or to get into your point of view there.
Mm-hmm. Well, now we go to truth, because we have now established that love is the starting point. Love cannot lie, so love is also connected to truth. So now I'm going to truth. And what is truth? What is truth? What is not truth? Truth is not simply what works. I will state a couple of things, and you can agree on me later.
Well, I think the dictionary of truth is, or the dictionary definition of truth is a statement that is not in conflict with reality, right?
Well, then you have to define reality, and that's for everybody different, right?
No, not really.
For you, it's a sphere, and for me, it's flat.
So no. Whether the Earth is sphere or flat is irrelevant to what reality actually
Well,
is.
there is only one truth, is there, or are there more truths?
There's one reality, and there are various like everybody perceives it a little different, but there's only one reality as far as we're
And is
aware
that the
of.
truth?
Statements about it are true. Yes.
So there is an absolute truth.
Yes.
Okay. So, but what truth is not is simply what works. What truth is not is simply what is coherent and understandable, because you can have a group of people and you can form a conspiracy based on a set of falsehoods and they still agree.
Yeah, right. And we compare this to reality to check if it's true.
Yes.
If it's in conflict with reality, then it is not.
Exactly. So truth is not what makes people feel good. Unfortunately, bad news can be true. Truth is not what the majority says is true. For 51% of a group can reach to a wrong conclusion. Truth is not what is comprehensive. A lengthy, detailed presentation can still result in a false conclusion. Truth is not defined by what is intended. Good intentions can still be wrong. Truth is simply not simply what is believed. A lie believed is still a lie. And truth is not simply truth is not what's publicly proved. A truth can be privately known, for example, the location of a buried treasure. So you said there is an absolute truth, and I agree, because if you say there is no absolute truth, well, then that's a self-defeating mindset. So I'm glad that we can agree on that there is an absolute truth here. So that's what we want to establish. We want to establish truth in both of our statements, whether the Earth is a sphere or it's flat, right?
Yeah. All right. So how do you come from your presupposition to the fact, or why do you think starting from the presupposition that the Earth is flat?
Well, I want to know the truth, and I don't want to make up stories, and I don't want to be to fall in those traps that I just stated, because what I hear most of the time is that my model works. Truth is not simply what works. You understand? So that's why I say people say that they have the truth, but it is not always the truth.
Yeah, right. And we can check if they're saying the truth by comparing their statements to reality.
Exactly. But then we have to know to establish the reality. So, okay, so that's what I wanted to say first. And I'm going to go to the things that I wanted to answer you about.
Yeah, so right. Is it okay if we go to the argument and start with the stars? Because
yes. The first two questions that I wanted to answer, and I want you to bear with me also, because this is a thought experiment that I wanted to go through, just to come to the truth also, and also to give you a certain perspective. And I gave you the definitions of perspective, to look at it in a particular way or considering something, and I want you to go with me in this thought experiment that I have. And
all right, but there's one thing. When you're talking about perspective, you then should always make clear which of the four cases you are currently talking about.
Because that's what I said now.
Right. So it's a common tactic to actually mix up the definitions. So whenever you're talking about perspective, please explain what exactly you mean by that in that particular statement.
So now I try to get you into the thought experiment and to have you see it in a particular way or considering something. Just consider something in a different way. So the thought experiment is about this one. And I did this in Rhetoric's Hangout. Did you go back and see it?
I watched a part of it, about half of it, I think.
Okay. Yes, it was quite a long time.
Yeah, it was 2.5 or 3 hours.
Yes, it was. So question one in the thought experiment: you are in a big expanse and there's nothing in it. How would you know? How would you know that you are moving or that you're not moving?
You can't tell. As long as you're not being accelerated, you can't tell.
But even if you are accelerated, if there is no air to rub against, then you wouldn't feel it, right?
If you are accelerated, you can feel it, yes, because you actually have organs to measure acceleration.
But the organs only work in an atmosphere.
No, they don't.
Yes, they do.
No, they don't.
Then I want to see the experiments done.
Well, even if you're underwater, for example, you can still feel which direction is downward.
Atmosphere, or that is it's a medium, and in a vacuum there is no there's no medium there.
Sure, but the inner ear, the way that it is made, is pretty much completely encapsulated. There's no connection to it whatsoever to the outside. It doesn't matter if it's in the vacuum or if it isn't. As long as there's an acceleration, the inner ear will register it.
Okay, but you're moving or you're not moving.
You can't tell movement by it, only acceleration. So you can't tell if you're moving or not.
Okay. So the next question is then, someone else is in the expanse with you, and that one looks like he's moving, or maybe you are moving. How do you know which is moving?
You can't tell.
Okay. Then question 3, there are multiple people in a distance from you, all moving, all directions, upside down, all the way, all over the place. How would you know they are moving or that you are also moving in relationship to each other?
I actually need a clarification. So they're all moving in a straight path, right?
No, all different directions.
All different directions, but straight paths. They're not being accelerated.
No,
then
just moving.
Multiple people. Let me think. I think. No, I think you still wouldn't be able to tell.
Exactly. Okay, that's what I would think also. By the way, so we'd have the same 3 questions. We answer the same thing.
Right.
About this. Yeah. Those people in questions are now not people anymore, but they are lights in different colors and different intensities. So all the people that you envision it, all the people are now lights in the sky. How do you know you are moving or they are moving?
Again, still moving or rotating?
Whatever. That's what you think then.
Still, when you're only moving in a constant direction with a constant speed, you won't be able to tell a difference. But if you're being accelerated, you will be able to tell a difference.
But we didn't talk about acceleration. We only said movement.
Yes, so still no.
Exactly. Okay, and how do you determine what those lights are?
By zooming in, first of all, by using measurement devices in general, like telescopes. Spectroscopy, for example, can be used to determine what it is. That kind of thing. So you use scientific instruments to actually try to gather as much information as you have.
But you are now you're in an expanse and you have no measurements, nothing, not anything. You're just there. You're just experiencing.
So you're just seeing light points, like point sources. Then there's nowhere to tell.
Okay.
But this is a position we are not in. We have scientific measurements, scientific tools.
We come to that later. That's okay. It's just a thought experiment. You have nothing there. Only your senses. Only your senses are doing this, right?
Right.
Yeah. So now you're not in that expanse anymore. You are on the ground.
Okay.
And now still those points of lights are doing all kinds of things in the sky. Now tell me, what does this have to do with the shape of what you're standing on?
Simple, because when we take a look at the stars, we can actually see the directions they are taking. And we can, by measuring angles, for example, we can derive what surface of the planet we are standing on. So if we have the tools to do it, we can do it. In your hypothetical scenario where we have no tools, it's hard to do it because by definition, we can't gather any information apart from the one that is going into our senses directly.
I didn't say that we had the measurements or all the other things that you say now, like spectroscopy and all the other things.
Spectroscopy is a secondary thing. The first relevant one would probably just be a measurement device to determine angles. That's the easiest way.
But if you are standing on the ground, you have no way to know the shape of the Earth just by looking at stars or different colors of lights in the sky. right?
Well, if you're able to change your position on the surface of this, on the surface in general, then yes, you can derive information from it.
Well, that's why we disagree. That's why we disagree.
Well, yeah, I mean, in your scenario, when you're walking in one direction and the angle towards the start changes, then yes, you can use mathematical models to find out what shape the surface or the surface in general has, right?
No.
Sure,
That's
you
really
can.
ridiculous. That's absolutely ridiculous.
Why? It's called geometry. You can use it.
No, it's not geometry. It is perspective, and that's the art form of perspective that I'm now referring to. Because if you move away from Polaris, for example, from the north to the south, then Polaris will dip to the horizon.
Right, and on the equator, it will be directly over the horizon, like at 0 degrees elevation, right?
Well, that's your story, yeah.
And I mean, you can go to the equator and measure it.
You can measure an angle on an apparent horizon, but that's only what you
measure. You don't actually need to use the horizon. You can actually measure going directly downwards, and you can reference that angle. That's a possibility.
But still, why do you think then that we are living on a ball then? Because it's also possible on a flat Earth.
No, it isn't, and I can show you why. I can show you why.
Well, let's do that later, because I want
no. Let's do this now, because this is, I think, a relevant point that we shouldn't let slide.
Well, we don't let it slide because we come back to it later. I want to, because I will answer your question first, how I see it. Okay, so we come back to it. I promise. We come back to it. Okay, so for me, now there's also a man, a renowned cosmologist, George Francis Ellis, and he said people need to be aware that there is a range of models that could explain the observations. For instance, I can construct you a spherical, symmetrical universe with Earth at its center, and you cannot disprove it based on observations. You can only exclude it on philosophical grounds. In my view, there is absolutely nothing wrong with that. What I want to bring to you into the open is the fact that we are using philosophical criteria in choosing our models. A lot of cosmology tries to hide that. So he says that it is possible to construct a model for geocentricity and heliocentricity. And
do you have the source for this? Because I suspect it might be a quote mine.
Well, I will provide it you later, because I don't know how to send it to you.
Well, how can I take his comment for granted if you can't provide the source?
This is a well-known quote. You can look it up. You can Google it and you will find it. This has been presented many more times in people's hangouts, so it shouldn't be a surprise to you.
No, I actually haven't heard it yet. It's new to me.
Oh, okay. Oh, well, that surprises me. So for me, it's a big step for some people, for heliocentrics, to go to geocentric. For me, as a flat earther, from geocentric to go to flat Earth is a small step. So, but we come back to it later, because you will give me scientific evidence for your spinning ball. So that's what I'm hoping for.
Yes, and that's what I would actually like to start now, because we haven't talked about any scientific evidence yet. So
yes, but I want to go to the next thing. But that's the last thing I will have, and then you can go.
Well,
okay.
Well, I think it makes more sense to just discuss it point by point, which is you're saying that using the stars. Well, Betty, you're saying that using the stars as a reference system to determine the shape of the planet isn't possible, and I say it is, and I would like to provide you the evidence now to find out why it is.
Well, I want to first do my presentation, because that's what what you told me that I could do.
Sure.
So please let me do this. I want to interact with you meanwhile, because I don't want it to be a monologue. So I wanted to have you interacted with me. So let me go through another analogy that I have. So if you will bear with me just for a little longer, and I will go to the art perspective, and then you can go. Okay?
Okay, that sounds fair.
Okay. So I have an analogy with a tree. So we are an ant on a tree. Well, we are the size of an ant on a tree. And the way you are going to define the shape is, well, we observe the birds that fly around the tree or the nests and in its branches, and we're kind of going to observe the stars, the moon that go overhead in different patterns. We are examining the soil. Wait a minute.
The shape of the tree itself, right? We want you're
We
talking
want to
about
know this.
finding out the shape of. Okay.
Yes.
Okay.
Yes.
Good.
So we observe the birds that fly around in the trees and the nests and the branches. You could also look at the when you go with the analogy, then you see meteorites, rockets, aeroplanes, satellites, balloons. Those are the birds that fly around the tree. You know. So,
Yes.
and then observing the stars, the sun, the moon that go overhead in different patterns, orbits, eclipses, light and dark, shadows. Examining the soil, the roots we are in, the roots that the trees are in, the Earth's core, boats over the horizon, plate tectonics. What does this have to do with the shape of the tree? So if you look at the shape of the tree, you have to witness it. You have to see it in its whole. And if you only are trying to see what birds are nesting in it, or the sun and moon, what has the sun and moon and stars overhead, going overhead, have to do anything with the shape of that tree that you are living on?
Well, because you can measure the angles to find out how the shape is. Again, it's geometry.
Yeah, no.
Yeah, sure.
Yeah,
I mean,
no.
for example, with the moon, we can determine the distance directly by triangulation. This is something that is quite.
It doesn't say anything on what you're standing on.
Well, yes, it does, because.
No, it doesn't.
Oh yeah.
No,
because
you're only measuring patterns and regularities above.
when we know the distance, for example, to the moon, right? That means that we have one. When you're then doing a triangulation, right? We know the distance of one of the three sides of that triangle. Therefore, we can determine the other two by using the angles. And this is something that's actually quite easily done. And this is the same thing we're doing with the stars. We can pretty easily show how that the stars are so far away that the light rays coming from them are approximately parallel. And using this information, we can then determine the shape of the surface we're standing on.
No, you can't.
Yes.
No, you can't.
I'm
No,
still
you can't.
waiting to show this to you. So.
Yes. Okay. So, well, with the tree analogy, I see no way how you can determine the tree, the shape of the tree, by seeing things going overhead in patterns and regularities, by seeing rockets and aeroplanes around it, by examining the core or boats going over horizons, plate tectonics. I don't see what that has anything to do with the shape of the Earth. I don't see it. But I will wait for your explanation later on, because we'll have plenty of time to do that then. I will go to the perspective thing. If you, I think that I can present this to you because it's more visual.
Do you need your screen shared?
Yes, I'll have to see if I can do this.
Okay, I should be sharing your screen right now. You just have to really activate your screen. So on the top left side of the window, there's this button which looks like a little display with a white arrow on it. Click on that and then choose. Yep, you got it.
Okay, can you see
there
this?
We go. Yes, I can.
Okay, so now we have the word perspective, and now it's used in art. So the way that objects appear smaller when they are further in the way. Well, let's go away with that. And parallel lines appear to meet each other in the point at a distance, or it's a point of view. So this is eye level, and it goes away in a distance. If this person was a little bit higher, he would have this line that goes to a different, almost a little higher up, but also in the same point on the horizon. Okay, so with the sunsets, it's like this because the sun is up above, and usually the people then represent it like this in two parallel lines, but the sun dips down, and dips down with the perspective line.
So
you see
wait a second. So which one do you think is actually the case?
the green one.
You think the green one is the case?
This is the case.
This is a little bit weird to show this in a two-dimensional system.
Of course. Yeah.
So you think the sun actually drops below the horizon on the surface? Or does
Yes,
it?
I believe that the perspective, because the sun is up high, but you have more points of perspective. This is one point to go to this point, but if you look up, you have a perspective line that goes up into a point. I can explain that to you later. But when you look at the sun and it's overhead, and you wait for the sun to come down, you will see that it will dip down and go further away.
No, it won't. It won't be further away. You can measure that directly as well by comparing the angular sizes.
Angular sizes has to do with also with the perspective, because when it's up high, it has also a perspective. It's the same height as it is further away from you.
Well, wait. It's yeah. So when the sun is further away from you, right? And you said yourself, objects shrink when they get further away from you.
Yeah.
Then if over
but it doesn't need to be. Doesn't need to be. It sometimes does, and it sometimes doesn't.
Well,
it also has to do with how your eyes are.
No, it has nothing to do with your eyes.
Yes, it does.
Betty, let me try to explain this to you. When you take a look at the sun over the course of the day and you use proper equipment, for example, a camera with a solar filter, you will actually see, and I think this was presented to you in the Hangout with Reds, that the sun or the size of the sun over the course of a day will not change. This is something that is not predicted by flat Earth.
I don't see why that should be, but this is my perspective on it. This is how I see it. I see the sun going down because of perspective.
But you're already making a mistake there. It's not linear. Like the height time correlation in your diagram is approximately linear. It isn't.
Well, it is two-dimensional, so we couldn't represent it the way it really should be.
Oh yeah, I mean you can.
But this is absolutely false. It's not like this.
Right. So wait. So your y-axis is indeed the height, or is it the perceived height?
This is the y-axis. You say?
No, I'm talking about the y-axis. This is the x-axis. Yes, that one, the vertical one. That is usually referred to as y.
Yes.
So is that height or is it perceived height as seen from the observer?
Perceived height. Well, yeah.
Okay, great. Yeah, that's all I wanted to know.
Well, then you have also here the Polaris. It's in the middle here. So here this is the actual Polaris, and when you stand here on the Earth, on the flat Earth, you will perceive it like in an angle.
Right, but when you go further south on the diagram, you should see Polaris as well, right?
When you go here, this dips down to the horizon, and you won't be able to see it when you are more here.
Why? I mean, why do you think
because that is perspective. That is the rules of perspective. That's what it does. And that's
no, it actually isn't, because when we're talking about the stars, we're obviously dealing with light rays which travel in straight lines. That means when you're going towards, or in this diagram, south of the equator, you should still be able to see Polaris, because there's no obstruction between, there's nothing obstructing the light ray coming from Polaris between the Polaris itself and you. There's nothing in there. Therefore, you should be able to see Polaris. We don't see that, therefore the Earth is not flat.
Perspective makes this star dip to the horizon, and then it will be obstructed by atmosphere. And like I said, atmosphere. You are moving yourself from that point, and this will drop down. That's perspective. You have to have a little bit of spatial awareness. If you are not having this, then you will not see it ever.
Okay, so please do me a favor. I see you're using Microsoft OneNote there. I know it has a drawing tool. Can you do me a favor and draw a little stick figure in that diagram south of the equator?
How do I do this?
Yeah, just use one of those pointers.
Yes, and what do I have to do?
There's like this drawing tool. It looks like a hand with a finger and a red line. It's right next to the.
This?
No, further up.
This?
There we go.
Yeah.
You see that? No, a little bit further up. No. The menu. Right, go to the right.
This
that one. Yes. Now do me a favor and draw a little stick figure in like South America, for example.
South America, here.
That's the continent on the left side. And make sure it's south of the equator. The equator appears to be the yellow line, if I see that correctly.
This one, yeah.
Yes, right. So no, not directly on the equator, but left of the equator.
Left, this one.
Yeah, here? Approximately. I mean, you can go further south if you want, but whatever. Just draw a little stick figure there. Can you maybe make it a little bit? I guess it's fine. It's enough to see for me.
Maybe I should make it a different color.
Yeah, I think it's fine. Let me just check if the audience can see it on YouTube. Yeah, I guess it's visible enough. Okay, so now take a different color, preferably yellow or red. Okay, please draw in the direction which the light ray takes from Polaris to the observer.
You want this one?
Yeah, I mean from Polaris to the observer.
Well,
so the observer is now the
I would say that it would be going this way. Here is Polaris for this person.
Yeah, but we already established that Polaris. So do you think Polaris is visible for him?
You see this as a tabletop with this above it.
I mean, that's a simple question. Do you think he is able to see Polaris?
This one?
Yeah, this guy, the guy you just drew.
No, I don't think that he will be able to see it now.
And why isn't the light you just drew coming directly from Polaris to the observer? Why does it have to make this curve down?
It is not curved.
Yeah, I mean, you obviously
this
draw a direct
light is only dropping down.
The light is.
Yeah. Maybe this one will look.
Well, the light. No.
You said this.
Stop. Please go back to the diagram before that. Let's assume that Polaris is still the same object, right? There's no second star which the other guy sees that would be identical to Polaris. The light source for that light ray is still the same one. Then you must be able to draw a line from Polaris to the observer that would lead the light ray to a point where the other guy can't see it.
I don't get you at all.
Okay. So Polaris is sending out a light ray, right? Let's assume.
Well, it's not a ray; it goes all the way because it's like a sun. You said. It's your story, but
right, exactly. But I mean, obviously, only the light that is heading from Polaris in one direction will hit the observer, and that's the one that is relevant to the discussion.
Exactly.
So a photon is sent out by Polaris. Okay, and as you can see in this diagram, there's currently no direct. There currently is a direct line of sight between Polaris and the second observer that you just drew in. Okay, that means that theoretically Polaris should be visible to the observer, but you're saying he isn't, which I agree with. Polaris isn't visible from south of the equator. So this light ray that is exiting Polaris and that should reach the observer, where does it go?
Because when you move south from the north to the south, whichever way to the outer ring on the flat Earth, that star in your viewpoint, in your perspective point, like what I explained here, things look smaller and further away. It will drop down.
No.
Yes, it will drop down, and that's what happens.
No, the angle. Well, the angle will change.
You can see it. You can see, the angle, and that's also what you're measuring with latitude.
Right. You're measuring.
You're only measuring
the angle, right?
The angles, and there are not multiple polarises because there's only one Polaris, and it just drops down because of perspective. That's what I'm trying to tell you.
Right, but it's still over the horizon, right? And in your example in Bogota, that's. Wait, I think Bogota is still Oh, that's nice. In your diagram, Bogota is still above the equator, right?
Yes.
Okay, so Bogota
According to
is
this thing, yes.
well, according pretty much to every source, Bogota is north of the equator. That's a given. The equator is a little further
Well,
south.
I have that not the topography in my head, so
Yeah, I'm pretty sure it is right now. So in the diagram, you can already see that for Polaris, which is located over the North Pole, there will be different positions, right? So
no,
everybody,
there are no different positions. Polaris has the same position in the sky, in the night sky. But for the people on the Earth, where there are, that makes it seem to drop down. That's the only thing that I want to explain to you.
all right, and this is also expected. I mean, the angle change that you expect on a flat surface and on a spherical surface are going to be different, right?
And
they're not identical.
No, can you repeat? Because I didn't.
So when you're moving from the North Pole south,
yes,
there will be a change in angle towards Polaris. When you're directly on the North Pole, it will be directly overhead.
Yes.
And as you go further south, the angle
drop.
towards the horizon will go down.
And to drop down. Yes.
Right. But the amount of angle change is going to be different for the different shapes of the surface. When you have a spherical surface, the amount of distance you go southwards will be directly proportional to the angle change, which is not the case on the flat surface.
Well, I will beg to differ. This is the same. Because when you measure it with a sextant or whatever, you will come to this degrees.
Yeah, right. And
yeah, right. Because we are.
Right.
And first, you have to tell me whether it is flat or spherical.
No,
because this
I'm sorry,
has
but
nothing to do with the shape of the Earth.
I'm sorry, but at this
That's
point,
what I'm trying to tell you.
At this point, we will have to model it. I'm going to model this live right now.
Well,
so please do me a favor and take a look at my screen. Can you see my screen?
Not yet.
Wait, it's because I'm still sharing you. There we go.
Let's see if I... Okay, now I can.
Okay, so this is a geometry program called Geogebra. It's two-dimensional, and it's usually used to teach kids about geometry in school. So I got two windows open, and what we're going to do is we're going to model the sphere Earth, and we're going to model the flat Earth, and then we will compare angles. Okay? So I'm actually going to do this by scale. So I'm just going to look up the radius of the Earth.
I think I have seen you do this already. So I know where you're going to.
So let me try to show it. And whenever you have a problem with it, just ask me, okay? So
well, I have a problem with it already because this is not going to help me.
Well, I'm going to show you how it's going to help you.
No, because I've seen it already.
Well, I was bearing with you. It would be nice
if
you could take a look at this. Okay, so we have a nice model here. So this is pretty good approximation, actually. The difference between the equatorial radius and the polar radius is only like 40 kilometers or so. So yeah, assuming that it's spherical is good enough for this. Okay, and let's use a second program called Stellarium. So Stellarium is a planetarium software. Basically, you can plug in any...
I know, right. Because it's based on a ball, yeah.
Yeah, you can. Well, it indeed is based on a ball, but you can use it.
So you are presupposing it already.
No.
Yes.
No, wait. No, because
you presuppose a ball already in your Stellarium.
What I'm saying is, if you would actually allow me to let me speak, what I'm saying is this constantly yields accurate results. Whether this is based on a ball or not is irrelevant right now. As long as we can use this to simulate the night sky from different positions, it's valid, right?
So it's a model.
Right, but if I plug in your position somewhere in the Netherlands and we take a look at the night sky, you go outside, take a look at the night sky right now, it will be identical to what Stellarium will yield.
Yes, it's a model.
Right, so we can use this. And actually, let me just, because we need equatorial grid, azimuthal grid. So we got these two. And let's start let's go to different positions. Let's start with the North Pole. So this is 90 degrees north. Obviously, it's only 90. There we go. It's obviously still there, yeah. And we remove the atmosphere so we can see the stars. Right. So you see those two coordinate grids, the blue one and the green one.
Mm-hmm.
The green one, which one is which? Let me check. Right. So the green one, that's basically where this point, that is directly above you. Okay. And so when we go further south, for example, this will not change. Like this is directly above your head. This point here is directly above your head at any position.
Is that Polaris then?
Give me a second. When we go back to 90 degrees, then Polaris is there. We all know Polaris isn't directly at the northern celestial pole. It's half a degree or so off, but it's good enough to use it for navigation. Okay, so let's use the second equatorial grid. We're now at 90 degrees north. Let's go, for example, to 70 degrees north. Okay, so the two coordinate grids, that's weird. They are not identical anymore. You see that there's a distance between the two. And when we actually check where that is, so that's that line going through there, that's 7. So this is 70 degrees, the other one is 90 degrees, so there's a difference between the two of 20 degrees. Okay? So this point here, this 70-degree value will be identical to this 70-degree value. So when I plug in, for example, 50 degrees, which is approximately where I am, and you should be at 53 or so, then yeah, we expect that line to be at, give me a second, yeah, 50 degrees. So you see, the latitude position of you on the planet is identical to the change between those two coordinate systems. And this is something that the flat Earth cannot predict, or this is something that the flat Earth doesn't predict. This is something that is only concurrent with a spherical surface. And what I'm going to do now is I'm going to draw this into the model, or into the geometry program. Okay. So let's just draw in 2 more points, because I want the equator, and I want obviously the north and the southern celestial pole. Yeah, that's good enough. So 1 here and 1 there. Let me just use a little bit different colors so it's easier to identify them. Let's go for blue for this one, and let's go for green for this one. Okay. Yes. So the guy at the North Pole, he saw the light ray coming directly from overhead, right? I mean, we're talking about Polaris, or the let's do this correctly and talk about the northern celestial pole. So in his view, northern celestial pole is directly overhead. I will be using red for all lines of sight towards the northern celestial pole from now on. Okay, so for this guy, it's directly overhead. Okay, the guy at 50 degrees. Let's do an angle, right size. So that's from here to there, and it's against counterclockwise 50 degrees. There we go. So this is the guy at 50 degrees. So there we go. And we need this apparent horizon. There's a tool for that. So the black line is his apparent horizon. Let me just give that another color. Let's use light blue for that one. So the light blue line is this guy's apparent horizon, or this guy's horizon. And we need a point on that horizon, being that one, for example. And let's find out what his angle actually is. So parallel line, that one to that one. Properties, this one was red, dotted, there we go. So let's just measure the angle between his line of sight and the horizon. We could actually do this the other way around. It would be equally valid. So angle, right, 50 degrees. So the guy at 50 degrees north will get a value of the northern celestial pole over his head of 50 degrees. So 0 degrees would be his horizon, 90 degrees would directly be overhead for him, and 50 degrees is where the northern celestial pole is. And we could pretty much do this for every angle on the surface. I did another example with 70 degrees. Let's do that as well. So 70 degrees would be in, for example, in Northern Europe, Norway or something. One of those irrelevant countries. So again, he would have his horizon. That's the light blue line that I'm drawing right now. Okay. Need a point on that as well. And parallel line.
What was that pointer that you talked about?
Yeah, it's because to measure an angle, we actually need 2 points. So I need a point on that line, which this program doesn't yield. I have to plug that in manually.
Is that the apparent horizon that you're speaking about?
Yeah, that's so yeah.
That's apparent. Line. So not real.
No. This is geometrical. This is horizon.
It's an apparent horizon.
It's a geometrical thing.
It's an apparent horizon.
I mean, you could also
only an angular size.
Well, if you don't think the horizon itself is valid, then you could always use the different line, which is towards the center of the planet, so downwards. That's the other possibility. Either downwards or upwards. You will get a similar result with only being 90 minus the angle.
What I find funny is that you draw straight lines on a ball.
Right? Why not?
Yes, why not? Of course, why not? And make a point there, which is apparent horizon. This is not reality. This is drawing, but if we are going to measure it in reality,
we will get the same results.
We have an apparent horizon. So the apparent horizon. So then you have to presuppose a ball or a flat Earth.
All right, Betty, forget the horizon. Okay, let's use it.
No, I'd rather not.
Yeah,
okay.
Listen to me. Let's instead use something that is not dependent on atmosphere or anything. Let's use instead the angle. Do I draw this? There we go. So this line here represents your direction of sight directly overhead. Okay, so if you're standing on any surface of on any point on the surface of the planet and you look directly up, that's that line here.
Mm-hmm.
Okay, just gonna draw in a point there here as well. First of all, let's finish the other one. So that was angle and right 70 degrees was the example before that. Okay, now if you're saying that these angles aren't valid, what you can also use is the angle between this line here, for example, and this one.
What is that? That's the real height, the real above.
This one is the line of sight towards Polaris, and this one is directly overhead for the observer.
Okay, and why does this prove a ball? Because I can do that on a flat surface.
Yeah, right. Let me show this to you.
Because you have that blue line underneath there. Yeah, well, bear with me because I want to understand why you are saying this.
Right. What I'm going to do now is I'm going to show you how this works on a flat surface as well. First of all, I'm going to do this on a spherical surface, and then I'm going to show this what this would yield on a flat surface, and then we're gonna compare results. So again, let's take a look at this angle here. Okay. So this angle here is 40 degrees because obviously the total angle between this line and the horizon is 90 degrees. Therefore, if one is 50 degrees, the other one will be 40. And for example, over here on this position, angle, where is it? This sometimes. Therefore, we have 70 degrees here. Therefore, this angle is predicted to be 20 degrees, and it apparently is. Okay, so 70 degrees that angle and 20 degrees the other one. So let's model this entire thing on a flat surface now. Okay?
Yeah.
Okay, So the angles, we agree the angles will be identical in terms of what you actually observe. In what you observe, the angles will be identical. Let's do this to scale. What we need is the circumference of the planet, apparently. So you agree that the distance between the equator and the North Pole is approximately 10,000 kilometers?
I don't know. I really don't know.
Okay, so, well, you can pretty much directly measure north-south distances, and yeah, those are pretty valid. So you can extrapolate this. So in our model, let's just eyeball that. I think 10,000 to go for 10,000 is close enough, but let me just check this. So that would be circumference of the planet, circumference of the Earth. That's 40,075 kilometers. So yeah, let's go for 10,000. That's good enough. There's a distance there in terms of by 4, so that's less than 20 kilometers off. That's good enough, right?
Well, may I say something first?
Sure.
Because the longitude and latitudes are just conventions, right?
No.
They are just conventions that people made up. So now you are basing. Wait a minute. You are basing.
No, wait, stop.
Wait a minute. I want to have this out.
Wait, no. You asked me a question.
Yes, but I want to answer also this because you can answer me.
Yes.
I want to have
wait,
answer to my question. It is a convention.
I'm sorry. No, yes, and I'm saying it is not a convention, but you
yes,
still.
It is.
No, I'm saying
you're measuring angles.
Right. Therefore, it's not a convention.
Yes, it is.
No.
Yes, it is. You make a convention based on distance and angles. So what does that have to do with the shape of the Earth?
Let me try to explain this to you. So
I have seen this already, and I know what you're going to do.
All right. So what am I going to do?
Because you are going to draw lines and angles, and then you think that you have proven that there need to be multiple polarities on different heights, and that's not the case.
Pretty much.
Because if you go back to your previous drawing with the ball and the blue lines, you will see that you have the same angles on a flat plane.
No, you will not.
Yes, you have, because if you are taking one of the blue lines, which is a straight line, and you can still measure the angle to the 2 points right above you, and also where Polaris is at that point.
All right,
and you come to the same angles.
No, you will not.
Nothing. Yes, you will, because you have drawn it that way.
No,
it's only a contrived convention that you are measuring here.
This is not correct.
It's just measuring. It's just measuring. It has nothing based in reality. Nothing.
So you think that literally gaining data in the terms of angles or measuring in general has nothing to do with reality?
It has nothing to do with the shape of the Earth. That's what I'm saying.
And I'm trying to explain you why.
Yes, but you are not going to explain this to me this way, because it's not valid.
Of course it's valid.
No, it's not valid. It is a contrived convention. That's what I'm saying.
No, a convention is pretty much arbitrarily defined.
Exactly, it is arbitrarily. We have made up angles that you can make up on a flat plane and on a spherical plane.
Betty, the only thing that is arbitrary about this entire thing is how a full circle is defined. Like, what exactly is a degree? That is the only thing, the only unit, and of course the meter, the distance.
Everything is a contractive convention, but for that matter.
Units are units are conventions, right?
Mm-hmm.
All right. What other convention, apart from the units that we use, am I using here?
You are, when you go back to your previous drawing, you will see that if you have that blue line.
Forget the blue line.
I don't know, because
forget those two. Betty.
Well, you needed them.
No,
because otherwise you couldn't have made those.
I do not. Betty, I do not need those. I can use those lines that are in here as well. The only reason that I'm using the horizon line is because it's easier to demonstrate.
And then what you're now doing is presupposing a ball Earth.
False.
Yes, it's indeed you are false.
No.
That's true. That's
No.
true. That's the truth.
Betty, look.
That's Stellarium. This is a model.
Betty.
Beautiful model, by the way. It's beautiful.
The only
but it's
thing,
not based on reality.
Betty, the only values that I'm plugging into the geometry program right now, or the only value that I'm plugging into it is the distance between this point and this point in terms of angle. In this case, it's at 50 north, so it's 40 degrees difference. That's the only thing I'm plugging into the model, in the geometry model. That's the only thing I'm doing. Those two values, 40 degrees or 20 degrees, are directly the distances between those 2 points. That's the only thing I'm using.
Yes, and you can see that on a flat Earth as well.
And I'm trying to explain to you.
Took away.
Forget the blue lines. I'm telling you.
No, I don't forget the blue lines because you drew them in, and
right,
it was based on a flat Earth, and you can have those same angles.
Correct, Betty.
Alex.
Let me draw the flat Earth model now. Right. So we were at 70 degrees north. That's approximately 2,000 kilometers south of the North Pole. That's about here. And we had the 50 degrees north. That's about 4,000 kilometers away. Okay, so these points A and B in this model are identical to the points C and C1 and C2. Let's just draw these side by side. I think this might work. Yeah.
Really, this is false equivalency. What you're making here, it's not the same. It's not the same,
Betty. So
Alex.
Betty. So
Alex,
I'm trying to develop this with you now. So please do me a favor and answer me the following question. Those two lines here, this one and this one, how would they look in this model?
Not this way.
Yeah, but how would they look?
Listen, I explained you already. I explained you already how it works with perspective.
How would those look?
In the art form perspective, because otherwise you won't understand how I use the word perspective, because we are quibbling over words now. So you can't represent it in a drawing like this. It is not based on reality.
Well, the black ones you can.
Because
yes.
when I go outside and I presuppose that I'm on a flat Earth, I will still have those angles. It's a contrived convention to have those angles, and the model that you're using is just a model. No, it's not Betty, science.
I
wanted to hear scientific evidence for a spinning ball. And you're giving me drawings.
Well, what do you think a model is? What I'm trying to show you is
how... a model...
Betty, please let me speak. Do not interrupt me when I'm trying to explain something to you. What this is doing is what I'm creating here is a two-dimensional representation of the different possible surfaces, one on the spherical side and one on the linear side. So what we will use, Betty.
It's a false equivalency. You can't compare it like that.
Of course you can. Betty, which line is up on the flat Earth? So this line here represents the zenith of the both observers on the particular points. So answer my question, in which way do these translate to this model?
I see no relevance in either one of these drawings, because what you're doing is making a representation that is not based on reality.
Of course
and I showed you already in my explanation on perspective how it would work on a flat plane.
No, what you're saying is that there's something wrong with geometry in general, and this is not correct.
But how you're doing it, if you will, and by the way, I will tell you what a model is. The word model is reserved for situation when it is known that the hypothesis has at least limited validity. But in other words, your model is not based on a true scientific hypothesis.
No, that's not correct, Betty. Let me try to explain this to you. Why is this a model? Because it's a simplified representation. I'm only using a two-dimensional system here because the third dimension is irrelevant.
Alex, what I want to know is, have you got scientific evidence of your spinning ball religion? That's what I want to know.
Yes,
and
I do.
not these drawings, because it's what you said, it is only measurements and geometry. Have you got scientific evidence for your spinning ball religion? Please.
All right. So
Let us go to that.
right. So
please.
before I provide it to you, I actually need to know what you understand by scientific evidence. Because wait,
I will tell you.
Stop. Let me just finish my question. Because what you've shown, or what I've shown yet, is scientific by every definition. But you reject it anyways.
No, it's geometry that's not based on scientific evidence. Scientific evidence is the scientific method.
Right.
The scientific method is observe a phenomenon, literally
review, like the angle of the stars over.
Now, let me state the scientific method to you, because maybe you don't know it.
Are you kidding me? I'm literally a scientist.
Well, then you should know. Then give me a scientific hypothesis for the spinning ball, please.
Right. So, first of all, I already told you.
And not drawings, because drawings have it's only models, and that has limited validity. So go away with the models and go away with your drawings, because it's not based on reality.
Of course it's based on reality. Betty.
No, it isn't, because
Betty.
I showed you another definition and another way to see this in reality. These are drawings.
You're wrong. Let me try to explain this to you again.
Tell me again that these are not drawings, because then you are not telling the truth to me. Are we drawing in a drawing system, or are we looking at reality here?
We are looking at the model of it. But please let me speak for once. Okay, listen to me. The hypothesis is that on a spherical surface, we expect from different observers different angles towards the pole star. On a flat Earth, we also expect different angles towards the pole star. But those two angles from the individual observers are not identical. Therefore, we can go outside, measure the angles towards the different observers, and find out which of the two models fits. And it turns out the flat Earth does not fit, because it will yield different positions for the individual observers. That is not right.
Okay, so what is the test that you performed?
You go outside, you take a telescope or whatever, anything that has an angle measurement instrument in there, and then you take a look at the northern celestial pole. That's all you do.
Okay.
You don't have to use the horizon. A weight on a string will do it as well, because it will define this line over there, for example, for this observer. When you have a line with the string, you can determine the direction of that line, and therefore compare, for example, this angle. But you also already have, if you know the position of this line, you also know the position.
I don't know where you're pointing at, because are you still pointing at a drawing?
Yeah, on the right side. Can't you see it?
No, I'm sorry.
Oh, wait a second.
But still, we are talking drawings, and there's no scientific evidence. And you stated a hypothesis. So your hypothesis is what exactly?
I already told you.
So the Earth is a sphere because what?
Because
you observed.
We make the first of all, we make the hypothesis.
Yes. Based on an observation.
We can do the observation first. For example, we measure different. We notice when you go north and south, you measure different angles towards the different angles between the zenith and the northern celestial pole. That's an observation. Okay. The next step is there are various possibilities. Either, for example, you can use this to determine the distance to the stars. That's a possibility, or a hypothesis you can form for that. You can make the hypothesis that the stars are a particular distance.
Well, let's stay with the angles and Polaris then, because
that's what I'm doing literally all the time.
Okay. No.
Yes.
What's the hypothesis? What is your experiment statement?
Okay, the hypothesis: the surface of the planet must have a distinct shape, right? So. Is it flat? Is it spherical? Is it whatever, cube or whatever? It could be various things. And by using the angles that we can measure on different positions on the planet, we can determine that. Because the different models will have different results. And it turns out that any model of course.
No, models have limited validity. So you have to go back to the hypothesis. So you state that measuring angles, that's your experiment. You are measuring angles. And what do you test then? So what's your null hypothesis? And how do you explain the independent variable? What do you...
Well, the independent variable is defined as the variable that you plug into the experiment, that you are able to change to do the experiment. The independent variable,
what do you change to do the experiment then?
The latitude.
So you change latitude? That this makes no sense. Because you can... Then you have to presuppose something.
Betty, you go north and south. Is that valid to do?
Yes, but is it a test?
Yes.
Can you change the shape of the Earth?
Betty, not Debbie. Sorry, I'm mixing you up all the time because you behave in a similar way.
Yeah, thanks.
Yeah, you do. I'm sorry. Is it valid to measure the distances between 2 points on the surface of the planet?
You can measure every distance that you like, but how can you manipulate the independent variable? What's your independent variable? What do you manipulate?
I already told you the
latitude.
The latitude. You go north and you go south.
So the latitude, the shape that you're on, the latitude that makes up a ball or a flat Earth. That is ridiculous.
No.
Ridiculous.
No, I'm not talking about the angle. I'm talking about the distance.
I'm not talking about the angle either.
Right. So
what therefore, are you manipulating so that you have a testable and falsifiable, repeatable experiment?
I already told you.
What are you experiment? You are only measuring things. So let us go to a scientific hypothesis then.
Measuring something
isn't a scientific hypothesis.
Listen to me. A scientific hypothesis.
I am listening, but are not giving me a scientific hypothesis yet?
Oh, of course I did.
No, you didn't.
Yes.
Not a valid one. You're giving me models. That's what you did, and those have limited validity.
I'm drawing this because I'm not able to show you a 3D representation of this. I'm doing this in a 2D space to make it easier. Do you understand that?
I understand, but it's a false equivalency. That's
in what way?
Proven, because you cannot draw it in a 2D thing. And I proven to you that if you go on back to your drawing with on the ball and with the blue lines which you removed, then you can have on a flat plane the same angles measured.
No, you cannot.
And what you did is going back to the other explanation, and that will give you a false result.
Listen.
And that's why it's a false equivalency.
I'm gonna do this now anyways. I'm sorry.
This isn't a scientific evidence. Let's go to scientific evidence for your spinning ball, please.
Look at my screen.
Well,
look at my screen. Look at my screen.
Yes, I am.
I'm doing this right now. I've been waiting to do this for 20 minutes now, but to keep trying.
Yeah, I'm waiting for a scientific hypothesis, but you don't.
Okay, so this is at 20 degrees, right? So
whenever you're ready.
Look at my screen. And this should be 40. Okay, so those black lines are identical to those black lines. Those two, this one is this one, and this one is this one. And this one, I don't think I have an equivalent of that here. Do I? No, I don't. Wait. So there we go. Okay, so those three lines, this one, and this one are identical to those three lines. This one, and this one. The only difference is that now we're on a flat surface. Okay?
Mm-hmm.
Good. So let's just find out what happens to the angle. So the angle here I draw in is 40 degrees. This is something that's measurable, right? And this one is also measurable. What happens is, as you correctly stated, those points, just to make this, oh, what the heck? I had a massive screen lag right now for some reason. So this one, and this one, and also this one. Okay, so again, you see, as you correctly predicted, those do not overlap. Right. So the independent variable in these experiments is the distance from the North Pole. So you got 2,000. You're on
How
the
can
North
you manipulate the distance?
by walking north and south.
Yes, but on a flat plane and on a spherical
Right.
Earth, you can walk around. So that's not giving me the shape.
Yes, exactly.
Can you manipulate the Earth to make it a ball or make it flat?
The independent variable is
What's the cause?
Betty. The independent variable is per definition not dependent on the outcome of the experiment.
The independent variable is the cause of the effect of the phenomena.
Right.
Observed. So what are you testing here? And what are you manipulating and isolating as the cause of the effect of the phenomena? What are you manipulating? You're only measuring angles.
I already told you. You're manipulating the distance north-south.
You can't manipulate distances. Come on.
Of course you can. You can walk north and south.
Yes, you can walk north and south. You can walk north and south on a ball and on a flat plane. You have presupposed a ball.
I did not, because otherwise I wouldn't be able to draw this. The left one. When you're on your AE map that you showed and that you used, can you go on your AE map?
Just for an example, by the way, but okay.
Can you go to the North Pole and then walk 2,000 kilometers south?
Yeah.
Can you then measure the angle towards Polaris?
Yes, but what have you done only but measure?
What else would you do? Measuring is all that science does, literally.
No, you have graduated recently. And by the way, congratulations on that.
Well, I'm still not a master of science yet, so I'm still bachelor. So
but you know what a hypothesis is. You know what a hypothesis is.
Right.
Okay, so you know that you have to manipulate. You have to isolate the cause and effect.
Right.
So what are you isolating here?
The cause is the distance. The distance between the North Pole.
No, the distances on a flat and an Earth, ball Earth. You have to presuppose an Earth, a flat Earth, or a ball Earth first. No. Yes. So your hypothesis is not valid. It is not valid.
Betty.
Alex.
So on both models, you can change the distance between the North Pole and your position, right? So for theoretically every centimeter that you move south, you can do this experiment by looking at your zenith, which is directly overhead of you per definition, and the position of the northern celestial pole. That's something you can do. Now there will be a function, a mathematical function that when you plug in your distance to the North Pole as the x value, that will yield the angle as the y value. And those functions will look different for different surfaces. For example, in this case, where you have a spherical surface, there will be a linear correlation. For example, let's talk about distance between. So we're talking about this angle here, right? So for example, 20 degrees. So there's linear correlation between you going further south and 90 degrees minus this angle. That means you go down one distance, that angle will be maybe 20 degrees, and if you go further south twice the distance, that angle will be twice that large. 3 times about here, you will end at this angle being 60 degrees. So there's a linear correlation between the two.
You haven't manipulated anything. You haven't tested anything. What's your null hypothesis? What's your null hypothesis? How can I falsify this?
You can falsify this by walking south and finding different angles that are not predicted by this.
Exactly. I only find your predictions and not my predictions.
I already told you.
Because you presuppose a ball.
Okay. No. Let's wait. Stop. Let's use your prediction. How far? Yes.
Let's do something else, because I'm through with Polaris and I am through with this quibbling over Polaris, where it is and whatever. Let's go to.
Oh, what the heck? Did she just left? What the heck just happened? Okay. I think, yeah, apparently she's back. Hello, can you hear me? Betty?
Yes.
You just left for like 20 seconds or so.
Yes. Yeah, you were gone also.
Okay, yeah, apparently it was you, so
Oh, was it me? What I didn't do anything.
it looks like it was you. It might be an interconnection or something. I don't know. So let's model this then on your model. How far do you think the
Geo,
poles
Alex, let's because we are not going to get this because this is not this is only measurements. This is not a viable hypothesis. Let's go to one of your other evidences for scientific evidences for a spinning ball, please. Let's go. Let's go to gravity or whatever. Let's go to something else and make your case with scientific proven evidence.
I'm gonna do this, but I want to know your opinion on this. How far is the pole star over the North Pole? How far is the pole?
How long are we going to go over this? Because this is not.
This one question, I promise.
Okay.
How far do you think the North Star is over the North Pole?
I don't know. I don't care, by the way. I don't know.
You have no idea?
I have no idea. And I'm not making up stories.
Okay, then let's talk about something else. Are you familiar with the Erdverse effect?
Yes.
Okay, then do me a favor and please state what it says or what it does.
Well, I can only so much say.
Yeah, I mean, I don't know the mathematical description of it as well.
Mathematics doesn't explain the cause and effect. Okay, so the earth effects, I know that it has to do with if you fly from east to west or west to east, that you will have more weight or less weight on that plane when you are on it. That's a little bit of what I know, and they claim that it has to do with the spinning of the earth and that it would prove the spinning of the earth. What I want to ask you is then, what is the scientific hypothesis of that aortic effect?
Okay, so when we are
and would you please write it out, because I want to see it in front of me.
When you are on a spherical surface, not on a spherical surface, sorry, on a rotating system, for example, on the surface of the planet.
You presuppose a rotating system already.
Yes, and to falsify this, we can. I'm trying to explain this to you.
Mm-hmm.
Okay, so when you're on a system that is not moving whatsoever, okay, then you don't expect to, or you expect to see. Let's just start with the flat surface. When you're moving any direction on a flat plane that is not moving, you expect the force downwards to be always identical, right?
I don't know. You tell me.
Yeah, you do.
Okay.
Okay. Now, let's suppose that this thing is spinning. It's still flat, but it's spinning. Do you know the feeling when you're sitting or when you're driving through a roundabout, for example, you just get like dragged outwards?
Yeah.
All right.
So centrifugal forces?
Centrifugal force, yes.
Yeah. Okay.
Okay. This is something you feel only in accelerated systems, for example, in rotating systems, basically only in rotating systems. So if you're able to measure some force that does that on the surface of the Earth, you can derive that it is rotating. And by comparing the value on different latitudes, you can derive that it's spherical.
Yeah.
So
I want to see the scientific hypothesis on that.
Okay.
So write it out.
So
what's the observed phenomenon? Let's begin with that.
Okay. So the thing you're observing, this is crappy to do. Give me a second.
You have a lot of icons.
I do.
Yeah.
And for some reason, my Chrome isn't working properly.
Oh.
Yes. I think that's a nice drawing somewhere. Give me a second.
I'm looking at one.
Right. So, wait, are you saying this is, forget it. Different subject whatsoever.
I know, just a joke.
I hope I can find a nice drawing of this. Let's start with, yeah, right. That's actually quite nice. So, this is great. So this is from Wikipedia. Again, your normal surface on a sphere.
Yeah, so you presuppose a sphere already, okay, but go on.
Well, I'm trying to explain to you how this would work on a sphere, and then we can compare it to how it actually
Then we
works.
are going to split it apart and take it into the scientific hypothesis, right?
Yes, yeah, sure.
Okay, thanks. Yeah.
So in this drawing, you have the rotational axis of the planet here. So the North Pole is there. And as you correctly said, you get centrifugal forces, right?
Yeah, if you are thinking that presupposing that you are on a spinning ball, yeah.
Yeah, so the hypothesis is that it's a fact that when you're in a spinning system, you will experience a centrifugal force, right? That's a fact.
No, you state it as a fact. I want to see the scientific hypothesis.
When you are in a spinning system, whatever that is, that might be a car in a roundabout, might be a carousel, might be anything. When you are in a in a rotating system, you will feel the centrifugal force. That's a fact, right?
That could be, yeah.
Okay, great. Okay. So the hypothesis is if the Earth is spinning, we will have a centrifugal force, and that will be different on different positions of the planet, because the centrifugal force, the formula for that. Let me just find this. I think I remember the formula. Yeah, there we go. That's the German Wikipedia site, but it'll do. So centrifugal force. Yeah, that's the one I have. So the centrifugal force equals the mass times omega squared. Omega is 2 pi divided by t. So t is the time it takes for one complete revolution, multiplied by r.
Wait a minute. This math is based on a spherical Earth.
False.
A radius. I see a radius.
Yes, but it's not a spherical.
What is not spherical?
This is the radius here is the radius of the circle in which the object is moving.
Okay.
So for example, for this carousel here that you see, the radius would be the distance between the center point of the carousel and the position of the.
But what is spinning here? The Earth is spinning, right?
Yes, that's the hypothesis. That's the hypothesis I'm trying to show you. Okay, so the radius. That's the radius in which pretty much the distance between the point of where it's turning and you. So in the sorry, it's the wrong one. Therefore, okay. So let me just use the other one that I've drawn already in Geogebra. So remove all of this. Don't need that. Don't need that. Don't need that. And don't need that. We do only need those two. Okay. So what is meant by radius in this case? We know the rotational axis here. That is this one. So make this. There we go. Oh, there's a green line somewhere. Don't need that as well. Okay. So in the terms of the rotational axis, the radius of the formula that you just saw, right there, this r, that is not the radius from here to here, but it's the radius of the circle that this person here is doing. So it's the distance between here, distance between there and there. That's this radius. And for this person, it's this radius. Obviously, I'm eyeballing this. Those lines are not completely straight, but whatever, it'll do. So you see that for those two people, you will expect different r values in this formula. For example, when you're directly standing on the equator, by the way, are you still here?
Mm-hmm.
Oh, you're so surprisingly silent.
Well, you want me to?
Sure. So when you're standing on the North Pole, this r will be 0, right? The distance between the axis and you will be 0.
Well, you are presupposing already a centrifugal force. Sorry, that's a difficult
No,
word.
I'm not presupposing this.
Because,
I'm forming the hypothesis.
Listen, okay. Well,
what I'm saying is, my hypothesis is that for different latitudes, you will get.
We are going back to the contrived convention again.
For different positions, north or south, you will get different r values. Therefore, because omega is always identical, it's always 2 pi divided by 24 hours and the entire thing squared. The mass, if you have, obviously you have to use a reference system, so you have one object with one exact mass, right?
What is the observed phenomena? What are you trying to say
I'm
here?
trying to explain this to you.
Now you are trying to explain something in mathematical ways.
Sure.
I want to, because mathematical ways are not reality. They are they're merely descriptions of reality, maybe. I want to know what is happening. What is the aortic effects in a real life event? What is observed here?
I'm trying to come to you, but I want to try to explain what is actually happening.
No, you're explaining it the wrong way around. You have to begin with what is observed.
Okay, what is observed?
Okay.
When you're moving westwards, I think there's another nice diagram. Yeah, there we go. Okay, that's great. Okay, so this is your observation. This red line is a data set, right?
Yeah. Well,
okay, this point here means that you're not moving east to west. As you see, this line is defined as if you go positive, you're moving eastwards. If you're going negative, you're moving westwards. Right.
Listen. I'm on a plane. On a plane. I'm on a. I will help you.
You mean an airplane, right?
Yes, because that's the aortic effect, right?
Yes.
I explained it a little bit in normal terms as how you can observe it, right?
Yes.
So
let's not say plane. Let's just say you're just moving eastwards to westwards. The means of transport is irrelevant.
So if I walk east to west, I will change in weight?
Yes.
So, well, that's great for women then, because where do I have to go to get a lot of weight off?
So let's take a look at this. So this reference mass in this system here has a mass of 10 kilograms. You weigh maybe...
How far west do I have to go to lose a couple of pounds?
And you don't... That depends on... Oh, fuck him. that was weirdly phrased.
It's really... Yeah, well...
No.
What is the phenomenon? What is the phenomenon? What is happening?
Let me explain this to you, goddammit. When you move...
Don't curse, please. I don't curse at you.
This is my hangout. I can fucking curse, so I fucking want fuck.
Well, do what you like, because
okay,
it won't be truthful then. It's not coming from love.
Listen to me. What the way you are measuring this is you move eastwards or westwards. The distance you're moving is pretty irrelevant. What is relevant is the speed with which you're moving, and you're moving your entire system. So you have a scale with a mass on top of it that is moving eastwards or westwards, and what you will see is that the mass or the force that the weight is that the scale is actually measuring will change depending on your speed. This is something that is expected.
Okay, so your speed is changing the weight that you have.
Right. So your speed is the independent variable, and your control variable, for example, is the mass.
So wait a minute, but how does this have to do with the shape of the Earth?
Yeah, let me explain this to you. This
what I was trying to show. And how can you manipulate the Earth or the spin of the Earth?
The spin itself, you don't have to. The only thing you have to manipulate is your speed east or westwards.
Okay, so there is no relevance to the spinning part of the Earth then.
You don't have to manipulate it. This is something we want to measure, or that we want to derive as a result of our measurements.
So how can you derive that? By walking or going in a plane, or
walking is way too slow. So you see that this scale here is in meters per second. So 465 meters per second. Let me just convert this. So this 465 multiplied by 3.6. There we go. So you have it's 465 kilometers meters per second. That's 1,674 kilometers per hour. You would have a difference in weight of a 10 kilogram object of 0.34 newtons. That's 34 grams or so. So if you're moving westwards at 1,674 kilometers per hour, your 10 kilogram weight block, whatever, will weigh 34 grams more. So that's the scale we're talking about here.
How can we falsify this? How can we falsify this? What's your null hypothesis then?
Right. So this is expected. This curve here is measured, and it directly is linked to the rotational speed of the planet. The point where this graph here is minimum.
Now you're presupposing the speed of the planet. So
no.
That's what you're trying to. That's what you're trying to prove. So that's not valid.
They can do it the other way around. What we expect is that when you fly westwards, or let's say this in general, when you're moving in the opposite direction of the rotation of the planet, right?
Mm-hmm.
Whatever that direction of rotation might be, when you move in the opposite direction, you will counteract the centrifugal force, because your omega becomes smaller. Remember that omega is 2 pi divided by t. So basically, the larger rotational time is the
what's
smaller
your independent
omega
variable?
What you're plugging it into this one. That's
what are you manipulating?
Your east-west speed.
And that has to do with the shape of the Earth and the spinning part of the Earth?
Yes, I'm trying. No. Yeah, sure.
No, of course not. You're presupposing a spin.
False. I'm measuring the spin. Listen to me.
No, you are not.
Listen to me.
How can you falsify this?
I'm going to explain this to you. If the Earth was stationary, you wouldn't expect this graph to be offset in the x direction. If the Earth were stationary, let's just say for example, if the Earth were stationary but spherical, this graph here would be symmetrical in terms of the y-axis. The y-axis wouldn't be here; it would be there, because the distance between your speed being 0 and the point where this graph is minimal, this distance here, that's actually the rotational speed of the planet on whichever latitude this was taken on. I assume it's the equator, because 1,600 kilometers per hour, that's approximately 1,000 miles per hour, which is always quoted by flat earthers. So yeah, this is on the equator. Right, this is on the equator. So when you're on the equator and you move westwards by 465 meters per second and you weigh 10 kilograms, you will feel 0.34, wait, this is newtons. Yeah, 0.34 grams, no, 34 grams more. You will feel 34 grams heavier. That's it. This graph is expected to look different depending on the rotational speed of the planet. And the result we get, this one here, is concordant with the Earth spinning from west to east with an equatorial speed of 465 meters per second.
No.
Right.
No,
sure. Of course.
You are trying to explain a phenomena.
Yes, the phenomenon is when you move east and westwards, your weight will change.
And that's then okay. So what's causing that? So what's your independent variable? What is causing that to happen?
Your speed.
My speed, does not the speed of rotation of the Earth.
Well, it's
And
it's
how can
both
I
in a way.
manipulate that so-called fictional speed of the Earth?
All you manipulate is your own speed.
So it could be something else then. There could
No.
be some other independent variable that makes that happen.
No. Oh, is it north?
You say no, but
east,
it's
west, yeah,
not
right.
proven. So what's your null hypothesis? How can you disprove this?
I already told you. The null hypothesis is if the Earth was stationary, this graph would be symmetrical.
Now, if the Earth is stationary, so can you stop the Earth? Can you spin the Earth?
We can model it. We can listen to me. Listen to me.
It is an invalid hypothesis. That's what I have concluded.
Can you please do me a favor? Look at this formula again. Gamma omega squared r. Meaning, if the Earth was stationary, that would mean that omega squared divided by r.
Now you're going to show me math, and math is only a description, so they can describe anything they want.
Known laws of physics.
Yes, but you can show me -4 apples, for example.
Oh,
show
for
me.
fuck's sake.
Yes, well, that's what you're showing me now here.
You realize
basically
that when we have a negative value in terms of speed, it's a positive value in the other direction. We just define one direction as being positive and the other one as being negative, right?
You're showing me math, and math is only a description. And I want to see an hypothesis that is really tested and manipulated and experimented upon.
I already told you.
And you are only telling me that the direction and the speed is causing something, but that should always also explain how fast we are spinning. That's ridiculous. That's ridiculous.
There's a phenomenon.
Invalid hypothesis. It cannot be tested, and it cannot be falsified.
Of course, it can be tested, Betty. There's
Alex.
The phenomenon is when you're moving east to west, the weight of a testing mass will change. That's a fact, right? Now,
that could be a phenomenon. Yeah, that could be a phenomenon. What is causing that?
It is a phenomenon. Okay.
So what is causing it?
Right. The hypothesis is that it's caused by the spin of the planet.
Okay, and what's the null hypothesis?
The null hypothesis is that the planet is not spinning.
And how are you manipulating that? How can you test that?
What you're saying is...
Don't you see the ridiculousness of your claim here?
Can you please stop speaking when I'm mid-sentence? You did this all the time now. And I'm getting tired of it.
Yes, of course you are, because you're cornered now.
No, I'm not cornered. I just want
to make because the hypothesis is not valid. I'm sorry.
Can you please listen to me for once?
I'm listening all the time. I'm waiting for a scientific hypothesis, and I'm not getting anyone.
I already told you. What happens is you measure that there's a difference in weight when you're moving east to west. What you also measure is that is not symmetrical. So, for example, when you're moving 465 kilometers eastwards, you will feel, or this 10 kilogram test mass will feel 1.02 newtons lighter. When you're moving 465 meters per second westwards, then this test mass will feel 0.34 newtons heavier. All right? Now, what we are doing then is we're making the hypothesis, okay, this is caused by the spin of the planet.
Yes, and the null hypothesis is?
The null hypothesis is that the planet is not spinning.
Okay, and how can you test that? How can you manipulate the independent variable?
The independent variable is your speed.
No.
Yes. That is literally what this is.
You are trying to prove the spin of the Earth. That's what you're trying to prove. That's what is in your hypothesis statement.
All right. Listen to me.
So you're not going to get any further here because you have no valid hypothesis. You don't know what a scientific hypothesis is.
I already told you.
You have to be able to manipulate it.
You don't have to measure directly. you can use known laws of physics to measure another variable to find out a different one. For example, in spectroscopy, you're not directly measuring the bond energy of things. You're measuring wavelengths of absorbed or emitted light.
Okay, so now we are going to something else then?
No, this is an example. You don't have to measure the thing that you're trying to measure directly. You can measure something else that is linked to the thing you're trying to measure.
No,
This is what
you
is
have to
happening here.
prove the thing that you want to measure. So you have to first prove that it is there, because you want to prove that the Earth is spinning or not. You're not proving that you are gaining mass or not, or losing mass. You are trying to discern if the Earth is spinning or not.
Right.
Well,
right. And there's physics.
So can you manipulate the spin of the Earth? That's my question to you, Alex.
Betty, it is known that the centrifugal force is a thing, right? In any system, in any rotating system, the centrifugal force is a thing. You can measure it, or you can design a system which has...
Prove your centrifugal forces then. Where are they?
This is what I'm saying right here. This difference between... This height difference, that is, in this case, the adverse effect. Between the minus 0.34 newtons and the 0 newtons. That
it is not a valid hypothesis. You cannot prove the spin of the Earth this way, because you cannot manipulate it.
I already told you, you don't have to measure it directly.
Well, you have no valid hypothesis, because if you say that you can manipulate or only are walking one distance and gain weight, and walking another distance and lose weight, what does that have to do with the spin or the centrifugal forces?
I already told you. How many times again do I have to tell you?
Something else, totally something else doing that effect. How have you isolated that effect?
Because it directly corresponds to the mathematics.
And mathematics only describes, and that's why mathematics is not reality.
False.
That you can say that.
The only thing that we are trying to find out here is that omega. We know that m and we know that r. For example, when we are on the equator, we know the r. Yeah, we know the r, and we know the mass. So what we're trying to find is that omega over there.
Okay, so the mass is the mass of the person.
Yeah, I mean the testing object. In the case of this diagram, it's a test mass of 10 kilograms.
Okay, and the r was the what?
The distance between you. No. The distance between you and the rotational axis.
So you are presupposing a rotational axis. Yes.
No. Well. Yes, I mean because listen.
Because that's why
listen.
Going through
listen. We are presupposing this R. Okay, let's say we're presupposing this. For example, Earth being spherical, we know the R. Okay, all we're trying to find out here is that omega. If the Earth is stationary, we will usually have that FZF centrifugal force being 0, because that omega is 0.
Okay, yes. Prove me the experiment. Show me the experiment.
Right. So again.
No, not a graph. Show me the experiment.
I'm sorry.
Show me the experiment, because there must be some sort of experiment statement that you have.
Yes, you
made up. Not a graph.
You sit in a train or whatever, and you're moving east-westwards. There's a scale in the train, and on that scale, there's a test mass. That's your experiment. That's your setup. And the only variable that you put in is the east-west speed. So you have a giant lever somewhere that is able to manipulate your east-west speed. That's everything you're doing in that experiment. You're manipulating your east-west speed, and what your output of that experiment is the difference in weight of the test mass on that scale, right?
So I'm sitting on a train.
Yes.
and I'm going westward.
You're
And
going westwards. That's in this direction.
From east to west, let's say.
That's to the left. Yes.
And then I'm losing weight.
No, you're gaining weight.
I'm sorry. Then I'm rather go the other way.
Yeah, whatever.
Okay, so then I'm going eastwards.
Yes.
Right?
Yes, you will feel a little lighter.
And by going on a train eastward with a velocity or a speed, that is an explanation that the Earth is spinning.
Right, because it's not symmetrical. Because
Okay,
what's happening?
nice.
Look,
Nice.
look. Because when you're moving at those 465 meters per second westwards, and you're on the equator, let's say you're on the equator because it's an easier case to calculate. That means that the Earth is spinning at those 465 meters per second westwards, and you have the same speed eastwards. That means that the centrifugal force is completely annihilated, because this omega squared becomes 0. Because usually it would be 2 pi divided by 24 hours, or whatever that is in seconds, 84,000 something, I guess. But since you're moving in the other direction with the same speed, that omega becomes 0. Therefore, your ZF becomes 0. Therefore, the only thing you then feel is gravity. And therefore, that's the minimum of that graph. That's the minimum of that graph. When you're moving faster westwards, you will actually move in the other direction, literally from seen outside. That means that your omega squared is going up again, which means that you will feel a centrifugal force, which will counter-affect gravity. Therefore, you will start to feel lighter again. And the fact that this minimum of this graph is not at 0 proves that the Earth is spinning.
Yeah, in your fantasy world, it would be, yes.
No, I'm sorry, this is not a fantasy world. This
yes,
is
it is.
First or second
because
semester physics.
I've shown you already that you have no viable scientific hypothesis.
No,
but
this is not correct.
So
I want to ask you a question. Have you ever taken any physics courses, like first, second semester physics in university?
Now we're going that road.
No, I
listen.
I want to ask you, because you seem to be completely ignorant on any physics.
Yes, and you seem to, because you don't know what a scientific hypothesis is. So, yes, what the F? Yes, that's nice. Fine, thank you. Let's go to gravity then, because you mentioned gravity.
Yes.
Okay, so which gravity?
What do you mean by which gravity?
Which gravity? Newtonian Cavendish gravity or Einsteinian gravity?
The one is a result of the other.
Okay, but which gravity are you going on? Is it the force or is it not a force?
Yeah, it's a force.
Okay, so Newtonian gravity then.
Right.
Okay, but the scientific community doesn't follow Newtonian gravity.
Oh, yes, it does. For a good approximation, it's right, and it's actually the result of Einsteinian gravity. So yeah, the force of gravity that you feel is a result of space-time bending.
Okay, let me go to a quote. Let's see if I can find it for you. Let's see. The Newton implosion. Einstein created his general theory of relativity, which provides our modern understanding of gravity, which the express purpose of expunging non-locality from physics. Isaac Newton's gravity acted at a distance as if by magic, and general relativity snapped the wand in two by showing that the curvature of space-time and not an invisible force gives rise to gravitational attraction.
Right. So what?
So the scientific community doesn't follow Newton anymore. So
that's no. You have. I think you're mixing something up. The phenomenon and the mathematics behind it is still the same. Only the cause has changed. And what Newton did was presuppose, okay, masses attract each other with a force that is dependent on a gravitational constant and their distances and their mass.
The gravitational constant, Cavendish.
Cavendish, yeah, might be.
Okay. So might be or is?
I don't know who measured it first.
Okay, but usually it is mentioned by the Cavendish.
Yeah, probably. I'm just not sure if it was the first experiment to measure the value of big G.
Okay, but are you know what Cavendish
Yes, I'm
experiment
aware of
was?
it.
Okay, so can you explain that to me in a scientific hypothesis then also? Cavendish?
Yeah, pretty much. He had one metal and one. He had two spheres with a known mass,
Mm-hmm.
and they were. One of them was fixed on a solid position, and the other one was dangling on a torsion pendulum.
Mm-hmm.
And basically, do you know what a torsion pendulum is?
Yes, I know the Cavendish
Do you know what a
setup.
torsion pendulum is?
It is something hanging on the ceiling, and it can move.
Yeah, that's not all it is. Basically, a torsion pendulum says that when you actually turn the scale that is dangling in one direction, the pendulum will actually load a force, or the pendulum will apply a force on the dangling objects. For example, think about it as.
Can you show a picture then? Maybe that's.
Well, basically, there's a force that is proportional between the angle you are turning the pendulum and the force. So you turn it by 10 degrees, the pendulum will feel a force of, let's say, 1 Newton. You turn it 20 degrees, there will be a force of 20 Newton. So twice what I said before. That's what the torsion pendulum is. And what Cavendish derived was a methodology by which to find out the value of big G, which is a gravitational constant, based on the movement of the torsion pendulum. I think on the frequency of it.
Okay, so what was the hypothesis that he? What was the phenomenon that he?
Well, the phenomenon itself was the attraction between the two spheres.
Okay. And what was his hypothesis then?
That he was trying to measure the value of big G. So his hypothesis is that when you, for example, increase the distance of the two parts, you will feel a different force. And from that, you can derive the value of big G.
He was trying to measure.
He was trying to measure
attracting masses.
Force. Yes, right.
Okay. And what was the null hypothesis then? How could we falsify what his big G experiment was?
Well, if his mathematics wouldn't have worked out, for example.
His mathematics? No, the mathematics is what he later described. But how can we have a null hypothesis on that Cavendish?
I don't actually think that's the case. I think he knew the formula for gravity before that. He just didn't know the value of G, so he was plugging in the.
So he presupposes also.
He knew that gravity was a thing beforehand. The only thing he didn't know was the constant. That was what he was trying to find out. So in the end, he had a big formula with the constant on one side and all the other plugged-in values on the other side.
Interesting.
Solve it for the value that you want to have, and then plug in all the values that you get, and then you had G.
How could he manipulate the effect that he was seeing?
By varying the masses of the spheres, for example, or the torsion pendulum constant.
But what about the Earth itself? Couldn't that have...
The Earth is not relevant to that. The Earth is not relevant to that.
How can you say that? Because that's the biggest mass out there.
Because
why wouldn't those balls in the shed being manipulated also by the Earth itself?
Because it was attached. Because it was attached to the device in such a way that pretty much every single object in the experiment would be pulled down by gravity in the same way, so you can just subtract it out there.
You basically would have to do this experiment in space.
No, you don't.
Or on the moon or something else. Because
wait, stop. Are you saying that there's no gravity on the moon?
I don't believe that we are able to go there. So
no, I'm sorry. Wait, stop.
I don't believe in gravity at all. So
you just said if we want to make this.
I never said anything about gravity being on the North Pole or on the moon, I said they should have done this experiment if it was possible. It isn't possible on the moon, for example. And
yes, but you realize that
then you are really manipulating, and then you have an independent variable. If you're doing this mass attracting mass on a bigger mass, then you are already have falsified the experiment.
no, that's not right.
Yes, it is
No.
right, because
No.
you cannot presuppose this experiment to be true, because you haven't isolated all the independent variables.
You
here.
can, of course you have. When you know.
So we see an effect and we call it gravity.
Let me explain this to you. You interrupted me again. So what happened was he attached the devices in such a way that all parts of the device were exposed to gravity in the same way. Therefore, the effect between them is independent of the effect on all of them.
What are you manipulating?
I already told you.
You are only manipulating the sizes of the balls. Have you manipulated maybe using?
I already told you a second thing that
maybe cubes or maybe a straw.
I already told you a second thing. He probably manipulated, which was the force constant of the pendulum itself.
The pendulum?
Yes, you realize that pendulums have a, for example, spring pendulums have a constant. You realize that's the case. It's in newtons per meter. For example, when you have a spring and you compress it by 1 meter, you will feel, let's say, a force of 10 newtons. And when you compress it by 2 meters, you will feel a force of 20 newtons, so twice that. There's a linear correlation between those two. It's called a Hooke spring.
Yes, I've seen there's something of that.
Yes, and torsion pendulums can be described by Hooke springs.
Yes, and they can also break the springs, right? So it's only a model again.
Well, of course it is.
Because it has limited validity.
No.
Yes,
well, yeah,
I read that. I read up on that today, for example. So I know that.
Yeah, you still haven't given me any sources on that one.
I know, but I've read that. That's really okay. It's not mine as well, but
right.
okay.
So
we have
here's the thing.
We have the equation of gravity.
Yes.
And so G for me is not.
Do you actually know that? Do you know the equation for gravity?
Yes, I've seen it in front of me.
Please name it.
I don't know how to pronounce it, but I have it in front of me. F is, and then you have G M and 1 M2 over R seconds and a little 2 on the top squared. Okay.
Yes, one mass.
I don't know how
so the force of gravity is one mass times another mass times the gravitational constant divided by the distance between the two.
So we have big G. Okay. Yes, we have big G. So that's an experiment.
Just a small clarification. That's for point masses actually. When it comes to masses with irregular shapes, it will get a little bit more complicated because we'll have to do some volume integration, that kind of shit. But for 2 point sources, yeah, it's valid.
Okay, so we have 2 masses, big G, and we have the radius of the Earth.
No, R is in this case the distance between the 2 objects.
Oh, okay.
So, for example, in the case of the.
But if we are measuring the Earth or the whatever.
No. For example, with the Cavendish experiment, it's the distance between the 2 iron spheres, for example.
Mm-hmm.
So but that are.
Okay, so what are we measuring here?
The force between the 2.
Okay, so a number comes out, right?
Yes.
And what does that have anything to do with reality, number?
Well, you asked us to measure the gravitational constant, and that is per definition a number with a unit on the end of it.
Okay, so the F is a number, right?
No. Well, the G is. So the result of the Cavendish experiment is G. G equals, oh, fuck's sake, let me look it up.
Well, we have that gravity equation.
Gravitational constant is 6.67408 times 10 to the minus 11 cubic meters per square second kilogram.
Okay, but there comes a number out of F, right?
Yes.
And what does that have to do with reality?
That's the force you're feeling. For example, when you weigh, let's say, just 60 kilograms, you plug in 60 kilograms into that formula and the mass of the planet into that formula and the gravitational constant and then the radius of the planet, you will get the force that you're feeling, the force that is dragging you down.
Mm.
That's
and how
the
can
result
I
of it.
falsify that?
Go on a scale with a spring that is using a known Hooke constant and try to falsify it. If it doesn't match up, then there's something wrong with it.
So I would basically go to the moon and to know if this F.
Oh,
force...
no, you can measure forces, masses, for example. You can measure masses in other ways except for gravity. For example, masses in general are resistant towards acceleration. So if you have a known force, for example, some sort of, let's just say you strap yourself to a jetpack, okay? And you know that jetpack has a jet with a force of 10 kilonewtons, for example. Okay? Then F equals mass times acceleration. You measure your acceleration and you know the force of the jetpack. Therefore, you automatically know your mass. You know the acceleration, you know the force, therefore you know the mass. And if you then use that mass on that scale, you're able to derive yes, you know the mass, you know the spring constant, therefore you know if there's something wrong with it.
It's so not relevant to me. This whole equation is not. It is only a number. I can give you numbers. So
you appear to be denying anything that has anything to do with mathematics, and you don't seem to realize how important maths actually is. I mean, pretty much everything that is done in science, technology, medicine, technology in the sense of everything that computers are doing, anything that the industry is doing, that's all based on physics. And physics uses math.
Yeah, it uses math, but it only to describe things. It is not, physics is not mathematics.
But the results you get when you want to actually you know your input, the values of the variables. For example, when you want to know let's just go for crash tests. For example, you want a car that is resistant to crash, that protects the people that are sitting in it. And the way cars are designed today is actually pretty much completely digital. So you simulate the entire thing on a computer, and only then the first model is built, because you can't afford to build models that are then really crappy in crash tests. You can't do this in trial and error. What you do is you use mathematics, you use physics to predict the properties of a thing you're designing, for example, the car. And only after you've designed this using the physics that is known, then you actually build it. And you can be confident that your results will be close to reality.
Yes, but they have experimented and tested it and falsified it. Experiment testing, they have experimented it. You have to first observe a phenomenon, and then you have to make a hypothesis, and you have to have an independent variable, and you have to isolate that independent variable, what is the cause of the effect.
Yes.
That's okay. So you have to have a basis in reality. That's physics. That's what you can call, that's science. But mathematics only describes. It can be a description of a formula, but only after you've done the testing and have a valid hypothesis.
No,
Yes.
no, because you can actually just measure correlations. For example, you can measure
correlations.
Yes, for example, when you have
may I interject first?
No.
Correlations are not causations.
Yes, but you can still measure the correlations directly.
You are going away.
Oh, sorry.
Yeah.
So for example, let's just say you're in a vacuum and you're dropping rocks, right?
Yes.
Okay, so you're in a vacuum tube with a known height, and you have a rock that is always the same weight. You can measure, for example, on the x-axis the height, and on the y-axis you can measure the time it takes that rock to hit the bottom of the chamber. All right? You will get a graph, and the correlation between the height over the surface and the distance it takes the rock or the object you're dropping to hit this to hit the ground of the chamber, that's a correlation, and that will be, or you will be able to describe it with a mathematical function.
Okay, but then you have tested it. You have tested it with throwing a rock down and measuring how fast it.
Right.
Okay. So that proved my point.
Therefore, but when you then use that formula that you've gained, where you plug in the height and you will get the time, you can use that to predict stuff. Right?
Okay. Yes, but then you have a formula, and then you can use that formula. And
right, and this is exactly what is done in the entirety of physics. You make a formula that is demonstrably right, and then you apply it to new types of experiments that you're trying to do.
Yeah. No, not in every case. You have begin with a hypothesis statement with observing a phenomena. That's where you always begin with.
Yes.
And you might have, for example, some experiments already done. You might have a description, but you always have to test it.
Yeah, but that you realize the hypothesis can literally be a formula.
No.
Yes.
No. The hypothesis is never a formula in physics.
No, that's not right. You're expecting. Your hypothesis is, if this is correct, what I'm suspecting, then the result will be that, and the result will be a formula.
If this, then that. Yes, a causation. You have to get a causation. That's the independent variable.
Let me clarify. The result will not be a formula itself, but it will be a data set that corresponds to the suspected formula.
Again, sorry, I was distracted a little. I don't hear you anymore.
So,
what did you say?
So, I said that what you will get in the experiment is not the formula itself, but it will be a data set that corresponds to that formula.
Yes, and you have to, okay, and you collect the data. You collect after you have the testing done, then you collect the data, and then you make a description, maybe, if necessary, but that's not always the case. Because in germ theory, give me the equation of the germ theory. There isn't one.
Let's just ask Microblogganism. He's a biologist. He's in the side chat, and I'm pretty sure there's a correlation. Maybe in unlimited, where there's unlimited supply of food sources, I think you can pretty much get a nice correlation between the number of, for example, bacteria and the time. So I'm pretty sure there is a formula that deserves that name.
There is a formula to what?
So you were asking for a formula in the germ theory of disease, right?
Yes. So you can describe germ theory in mathematical forms.
Sure.
Okay. Well, let's see it.
Yeah, that's why I'm asking Micro if he's still in the side chat.
Interesting.
Wait, there's no math involved in that. So Micro, there should be a formula that describes when you have an unlimited food source for bacteria, how the number of bacteria is going to change over time, right? So you plug in a reproduction rate and you plug in a start value. That should be it, wouldn't it?
Interesting.
Biology, we don't math. Yeah, use math in most of the theories. You're right, but in this case, it's a correlation between time and the number of bacteria, for example.
Yeah. So it's an experiment, more or less.
Yeah, of course it's an experiment.
So yeah, so you have to have a viable hypothesis that you can test.
Yeah, right. Reality. The same was what we did here. We formed the hypothesis, and we checked if the data set wouldn't match up. And it works. And actually, I want to end this hangout now, at least the dialogue, because it's been 2 hours and 20 minutes.
Yes, it is.
So
late.
So usually I keep this hangout running for maybe half an hour, 1 hour more, but I want to open it for the for the spectators. So do you want to stay or do you want to leave?
Well, it's kind of late, so I think that I've proved my point that for the scientific evidence, you have given me nothing, only mathematical forms and nothing.
So I've given you nothing but data.
Yes, data which comports to non-reality. That's what I am coming from. So that's and I think I will leave, and then you will have your cluster F what you want to have.
And yes. Can you please do me a favor?
And
read Exodus 21.
I will read the whole book because there's more reality in that book than what you just explained to me.
No, but whatever. That's a topic for a different day.
Yes.
So again, thanks for joining.
Yes, thank you for explaining. Basically nothing, but okay. But thank you anyway.
Sure. So bye.
Okay. Goodbye.
So where are my oven gloves? Hey, Rumpus.
Hello. He offered you lots of experiments, Betty, and you just ignored them.
He's already gone.
Oh,
he's already gone. Actually, I'll be AFK for 2 minutes.
Okay. Oh, well, while you're doing that, I'll do a quick summary from what I felt about this goddamn thing. Oh, dearie, 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 dearie me. That woman is really devious. I mean, I think it's possibly her stupidity and her lack of respect for maths, but poor old Geo there, he was offering her, I think possibly because Geo was offering her diagrams first, what he could have done perhaps was something like his Polaris thing. He could have said, here, I've got this is my experimental data. I've got moving along from the poles, from the North Pole downwards to the south by a distance, and these are the observations I had for the position of the what was it, the moon or the sun? Yeah, the sun, yeah. And then said, so here's the table. Right, so now we need to have 2 hypotheses as to what shape of the Earth we're on, and we could have, for one, we'd expect this, and for the other one, we'd expect these other observations, and then match them, and then you could come up with the diagram. I think possibly she's allergic to the diagram. She's certainly allergic to maths, so really, her claim, anything with maths in it, because she doesn't understand maths.
Her problem is she kept saying something about like math only being a description, and then wanting him to explain it. But that, like, if he explains it in English, that is still a description.
Yes, that's right. What she didn't like, I realized this towards the end, if you have a description in text, I think she's more happy with that because she doesn't understand maths. But immediately you put that description into maths and saying, okay, let's put some numbers to this. What are our observations going to do with numbers? She couldn't cope with that. No, we're not allowed to do that. This is why she was asking about the germ theory and things. Anything that results in numbers, she didn't quite, I don't think she's got a cognitive dissonance here, but anything that results in numbers coming out, I think basically she's allergic to.
All right, I'm back.
Hey, Gio, I was just basically saying that this stupid bint, she really annoyed me, is allergic to any experimental hypothesis that includes numbers and then which outpop numbers. So I think possibly one way, with your Polaris thing, which is a perfectly valid experiment, you kept on telling her the independent variables, the distance from the pole, but possibly one way of putting it to her without having the diagram or maths to say, here's my table of moving along from the pole south. Here's my, just put a little table, Excel table, whatever, and then say, here's the observation that I get, and then you can say, and then you could say, here's my independent variable. This is the table. These are the observation I had, and then we could say, right now, then you could start drawing a diagram and saying, well, okay, which one of these 2 models then matches this data? Because she did sort of suggest.
You're being way too optimistic.
Yeah, I mean, I don't think it would work, but at least it would eliminate.
It wouldn't.
But at least it would get. She wouldn't then be able to use the argument, which is, oh, you're presuming the sphere of the Earth. You could just say, here's my.
No, she would. She would be able to use that because she wouldn't care that that doesn't make sense.
I'm really just a little flabbergasted by this. I mean, I asked her does or did.
Yeah, you asked her directly yes and no questions.
Yes, no, that's one thing. But in the end, did she really say, I didn't give her evidence, only data?
She said so many things like that. I didn't catch all of it. Yes,
She said evidences. She literally started at the hangout out saying that you have to have be in an atmosphere for your inner ear to work. Like she thinks there's apparently a hole, which would imply that there's a hole in there, so which would then ask her why the perilymph or endolymph isn't running out of your head. Like,
that was.
But no, Gio, there's no math directly involved with gem theory.
Yeah, what I was thinking about was like the.
You're thinking of the exponential growth of.
Right. Isn't that a part of germ theory? I mean, the number of viruses.
Germ theory is literally just germs cause disease.
Oh, okay.
That is putting it very, very simplistically.
Again, I was thinking too complicated.
Yeah. Yeah, you were too nice to her, Gio. I'm afraid.
Yeah, that's my problem.
But that's nice actually. That's good. It's better to be nicer than nastier than you. So but yeah, she was devious, and you could have pinned her down in a few more places perhaps. But as I say, she kept on being able to use the fact you'd drawn a diagram first and you were presuming things. But of course, when you're testing a hypothesis, you say, right, I'm going to presume this is the situation or that is the situation.
You assume a hypothesis in order to figure out what prediction it makes, so you can test
a presumption about your hypothesis is a presumption. This is what I'm going to propose. This is what I'm going to test, and does it match it? So it's perfectly reasonable to have a presupposition because you're testing that presupposition.
They do that on purpose, though. They do. They take what is the normal procedure and they make it out to be evil, so that when you use it, they can then say, "Aha! See, there you go."
And if it's got a formula in it, that's it. If it's got maths in it, that's it. What she didn't understand, so I was saying, Gia, while you were away, she wanted a textual description, but immediately like sensible people, we try and put that into a formula. She then thought, oh, no, you've done something naughty there. You put it into a formula with numbers coming out. No, I didn't want that. I want it's just text because she can't cope with numbers.
Probably.
Well, did anyone else get the sniff that she was coached, if not actively during, very recently by Quantum Eraser?
Yes.
Oh, yeah.
Yes.
I think what I suspect is that she watched Quantum Eraser's hangout with Oakley from 2 days ago, I think.
I actually suspect that the period where she suddenly started to become quiet, she might have gone and looked it up there. And then that wouldn't surprise me. I don't have any evidence for that.
Didn't hear her typing or anything, so no, I don't have any evidence.
The other thing that drove me nuts was when she kept on saying, can you change the radius of the Earth or other what we call controlled you could go on this actually, Gio. When she said she's an expert apparently on independent variables, but she doesn't understand apparently these controlled variables that you keep as a constant. And one of those, they might appear in the formula, they could be different, but for our experiment, we're going to keep them fixed. So we can just change one independent variable and then get another one. You keep the other variables, they're called controlled variables, and they're constant. So but just because you don't fiddle with those, that doesn't invalidate what you're doing with your independent variable you're picking on. Ooh,
but honestly, like her, the insult she flung at Gio that he doesn't understand the scientific method.
Oh God, no!
I have no idea how you kept your cool, because that is a fucking great fucking big insult, because you're a fucking master student in chemistry.
Yeah, I think you avoid getting too insulted.
By the way, I have something to announce. Today I had to talk with the professor, and I now have I found my work group for my master's thesis.
Wait, cool. So have I.
Nice.
Yeah, no, I think Gio got that right. I don't think you want to try and take insult necessarily. She's being an obnoxious twat, but I think if you start, feeling insulted all the time and trying to expand, I think Gio got it right. He just said, basically, don't be a
yeah.
But if you start taking
Gio was inherently me.
Sorry.
Gio, don't cross streams, man. Don't get your flat Earth debunking mixed up with your thesis.
Oh God, no. Holy shit! That
How do you even do that?
Chemistry proves flat Earth.
So I'm synthesizing chiral sulfoxides and the Earth is flat. What?
What?
I mean, I'm sure we can come up with something.
I mean, if they can do it, we can do
No,
it.
there's literally no correlation in there whatsoever.
Exactly. That's all you need is no correlation.
Hold on, wait, no. Presumably, some of them, some of the reactions you could be doing are dependent on pressure, on the outside pressure. So that would mean they're dependent on gravity.
Well, the ones that I already did in the same work group were pretty under atmospheric conditions, so
Yeah,
no.
and
yeah,
but
well.
they wouldn't. No, but they wouldn't work if you have them. It didn't have an atmospheric pressure. They probably wouldn't work.
So what? That doesn't say anything. The methodology of getting that pressure is irrelevant.
No, but that pressure is
That's
caused
why
by
it's a
gravity.
flat Earth proof. That's what you're missing.
Oh dear.
You have to do this like 7 degrees of Kevin Bacon thing here.
Oh, all right, I think I have to shut down 80% more of my brain to understand you. That's all right to say.
You have to find something that doesn't correlate at all, and that's how you come up with a flat Earth argument.
Yeah, you find two things that have nothing to do with each other, and then you put in some dots, random dots, and draw a line.
Did you understand her quote argument in the beginning? Like her presupposition thing?
No.
I missed that.
That was weird as hell. What the fuck? Quote, I start with love. What?
No.
She apparently thinks love is like an energy or like a physical thing rather than like an emotion.
Yes.
We had there was a classic on Earth Descriptions. There was a woman who claimed that love is force. That's what she believed force was love. You find this that people have no understanding of science, which clearly Betty doesn't. I bet she's never used a formula in her life. That when they can't understand the formula of the maths, they start appropriating the terms, then shoving them into an emotional context because they can't do the maths.
Right.
I wish you would just say math is just another language.
It's
Just say
maths.
that to her. Just say that. Math is just another language. Maths is just another language. Just say
sorry,
that.
right. So I thought you were saying
Just tell her.
Yeah, you're right. I should have said that.
well, it's a way of summarizing,
But
isn't it? That's
she
the
would-
point.
Right, but she would deny it. She would deny it anyways.
It's a formal language.
Maths is a fantastic way of summarizing paragraph of text. Instead of saying this is the number's going to come out here and it's going to do this and affect in this way, we've got a little way of summarizing it with these little formula things. That describe it perfectly.
I want to see the math summarization of work by Shakespeare.
Yeah, but that's not science, is it?
Saying you can't
I'm-
use math. Saying you can't use math is like saying you can't make formal arguments in German. So it's the same exact thing.
To be fair, you can't.
Wait a second. What?
Soundly, I like the analogy.
Yeah, I mean, saying you can't use math is like saying you can't make a formal argument in German.
But you can't make formal arguments in German.
Oh, you can't? Oh, my bad.
No,
Fickt euch
no one
alle.
knows that. It's a very specific feature of the language.
But it's quantitative. That's the great thing about doing it in a formula. It's a qualitative difference between we're describing in some text and describing in a formula. That's why we all think, oh, that's much better because it's going to give solid results. There's no ambiguity there in a formula, whereas there is ambiguity in bloody describing thing in text.
Exactly.
Ugh. She kept on going with you, G, on this. Oh, this other controlled variable. Every time you tried to pull something, you tried to describe something, she'd pull on you've got a radius in there. Can you vary that? And she used that again and again and again. These controlled variables, and you didn't hit back with, yeah, that's what's called a controlled variable. Don't you know that, you stupid bitch?
I did tell her that.
Oh, right.
What you just said.
What a control variable is various times.
What you just said, Rumpus, about maths removing ambiguity is the whole reason they don't want to use it.
Yeah.
Because they would rather sit around arguing about definitions in English and wasting your time.
And they don't understand it. That's the other thing, of course. I agree with that. They don't want to use it because they want to live in the ambiguity, but they also don't understand it. I think there are at least two reasons for it.
Well, I would say that there are some that understand it, and that's the bad thing, is that they should fucking know better, which means they're just
Who's that, Jared?
to the most.
Who's that, Jared? Who's it understands maths?
QE, quantum erasure.
Yeah.
No, he doesn't. He gets all his maths wrong. He doesn't understand about spinning atmospheres. He couldn't do an equation with I'm sure he didn't understand what acceleration. I bet if you asked him what acceleration is, I bet you he wouldn't be able to tell you. because he
No,
got so many other basic things
I
wrong.
had discussions with him early on where he would actually know enough about it to intentionally get it wrong. It's not an accidental error. It was intentional errors that I noticed with him.
He's read up a bit on quantum mechanics. So, for instance, he knows things like the terms like decoherence and a couple of other terms, and he can quote people. And he used to quote a couple of YouTube lectures out of context. But I don't think he's ever able to deploy them in a formula, or he's just able to quote little bits of techno babble at you. I've never witnessed him actually use numbers or a formula.
That's why he's gotten away from it.
Yeah, so when you said he understood the maths, I don't think he does. He understands. Okay, he understands the language to use, a sort of mathematical language and physics language, but he doesn't understand the maths. He might be right.
It's kind of he's kind of like a bad science fiction movie. Like he will use this language that sounds fancy but doesn't mean anything.
Yeah, it's
fraudulent. The old Star Trek technobabble.
Yeah, exactly.
It's all fraudulent. It really is. And so inferior. And she was doing the same thing. She was lecturing to you about an experimental method where you kept on telling what the independent variable is, the distance, but she didn't absorb that fact. All she knows is you've got a script, ask them of what the independent variable is and the dependent variable, and then ignore any formulas you say that's a presumption. Where can't you change the radius? And that was her basic mode of operation again and again and again. Ooh.
By the way, hey Sean.
Testing. Does this thing work?
Yes, you're just a little silent. I think I have to make you a little bit louder.
We can hear you.
I'm actually talking on an iPad because I'm still waiting for my computer to boot up from the hang it just had.
So, can you say something again? I'm trying to equalize you a little bit louder.
I'm just waiting for the PC to boot back up after it just hung up because reasons. I literally, as soon as I got in the Hangout, about 10 seconds in, the whole PC just hung.
Okay, so did you watch it?
I watched it till about maybe 35, 40 minutes.
Yeah, Sean gave up.
Oh.
Well, I gave.
I don't blame him.
Milu had to run away.
I gave up
Milu is
because
gone.
you gave her the independent variable on 2 different hypotheses. You gave her the null hypothesis on 2 different hypotheses, and then she still kept asking for them.
Yeah.
It's like, how retarded is this lady?
Yeah.
Very.
Do you not remember Betty?
Do you not remember she's the woman who said that the ground was shining light?
And she still hasn't defined perspective yet, other than to change the definition, twice within 5 minutes.
But it's something to do with art
and love, probably.
Yeah, art and love. That's all it is. Art and love, making you what you want to see.
Yeah, Sean's absolutely right. She kept on asking you for things you gave answers to, and she's used, I think, in a script to not getting an answer. So when you did give her an answer, she just ignored that, and then 5 minutes later, she'd then say, "But Geo, where's
it wasn't
the
even 5 minutes.
variable?"
It was within like 10, 20 seconds.
Yeah. I'm not sure she was entirely aware she actually got an answer.
Yes, correct. Agreed. Because she's not used to getting an answer, and when she didn't understand, she kept on asking. For instance, she kept on asking Geo what was varying, and the ATVOS effect. Geo kept on saying the independent variable is the speed. And she said, "Oh well, what happens if I'm moving east west? No, it's the speed. No, but what happens? So what's it got to do with the Earth rotating? No, it's your speed. And then what's I got to do if I go east to west? I've got to go east to west. Oh no, it's your speed." And he kept on telling her, but she just never, ever took it. What Geo I think needed to do was say, "Betty, I have just told you what the independent variable is. Could you please tell me what I told you the independent variable was?" And only by going that hard and that firmly do I think you then may force her to engage the gears and then come out and actually say, "Oh yes, I think someone may have said that, even if I didn't understand it. At least she should then be able to reproduce what you said."
Way too optimistic here.
No, when you pin them down at that. If you pin them down, they can't get away. You say, "What did I say the independent variable was, Betty?" He has no option. You
can't pin them down. They always find some bullshit to say.
Well, later on perhaps, but at least you could pin them down there, because she kept on claiming Geo had not identified the independent variable. Whereas if Geo had said, "Right, I've just told you what the independent variable is, could you please tell it back to me what I just said to you?" And Geo does this sometimes, it's quite good. He says, "Repeat back to me what I said."
She would just say something else than what he said.
Well, then you could keep on going and say, "Okay, no, you didn't get that right, Betty. Could you please try again? Or do you want me to tell you the answer?" And then get her to repeat that. Well, with a woman like that, I think you've got to be really, really firm and pin them into a corner, pummel them until you get an answer out of them. He was just like jelly. No,
that did sound wrong. You don't want to pin a woman into a corner and pummel them. You just don't want to do
Move like that, you have to be very
okay.
firm.
Well, this is a verbal pummeling with a gentle coercion, perhaps. Then be more appropriate. But
have a black letter sofa.
But I think you can, with these people, you have to get them into a corner and you have to make sure they can't get out of it, and really a very clear, concise question, and then say, right, have you understood what I've told you? And there we go. That's my theory anyway.
Oh.
It can be done. If they don't have control of the bloody mute on you, you can do that sort of thing.
Hiller, you're still muted. If you want to say something, you have to unmute yourself, I guess.
I'll say this, Rumpus. That's a good hypothesis, but it's invalidated because they never try. They will do everything they can to get out of that corner.
Yeah, but I think, but how could you get out of that? Could you please tell me what I told you the independent variable was? And if they don't go, could you please tell me what the independent variable was that I told you? And that is so clear, I don't think I could get out of that.
Well, if you're worried about how they're going to get out of it, think about this during Geo's hangout. She was fine with him drawing the Angelus to Polaris on the circle.
Right, but not on the flat Earth.
As soon as he started to draw it on the flat Earth representation, she was completely against doing that. She tried to change the subject so many times as soon as he started to show that flat line and how the angles would not work on a flat Earth. She wanted to avoid that like the plague.
That's why I was suggesting it possibly as an alternative strategy for Geo. Say, okay, here's the table. On the left-hand side is that little Excel table, whatever, Microsoft Word table. On the left-hand side, this is the distance from the pole. And then in the second column would be the elevation to the sun. That's all you've got. No diagram. Right. And then take it. So this is our data. This is experimental data. Now we've got two hypotheses. Let's take that into the two hypotheses and see what that does. And then she can't make the claim about presuppositions, although it's obviously perfectly valid to make a presupposition. So it might be an alternative way of Geo tackling this. Instead of coming with the diagram first, which she objected to, you could come in with just the data, the experimental data.
Well, I think it was important to draw the diagram first, just to show what data then I would use to plug it into it.
Yeah, but you're then making some. If you just start off, look, yeah, you see, say, I walked this distance. Yeah, don't. Well, yeah, I'm pretty sure it makes it clearer. But I think from her point of view, she didn't like. There is some wiggle room with her presupposition. You can say, here, I'm not making any presuppositions at all. This is what would happen. This is the data, experimental data that I can obtain. This is what we get. Right now, what do you propose we do about verifying what model is going to match this data? So yeah, I appreciate your answer for the explaining things to her about what you're doing and just having a series of a table. It doesn't make it clear. Obviously, if you were explaining it, you would start off with a diagram. But if you just said, "Here's my experimental data," then from her point of view, you're not making any presumptions.
Now that the PC's booted back up.
You sound much better.
Yeah,
Oh no, I'm gonna mute you.
That was good, Sean. Your Bilu thing. That was
all these silly imposters out there.
God, yeah, so yeah, I thought you did a good job, Gio, but I think you could have put them up as per usual. Of course, no one's perfect. I'm not claiming I'm either. I've probably done worse, but you could have pinned her down a bit more. But one can always do better in hindsight. Of course, hindsight's a wonderful thing.
Right.
I'm going to attach some mirrors to the front of his glasses so he's got hindsight, in the current frame of reference.
Yeah. Yeah, I mean, I wouldn't have thought of using the table first. I'd have done what you did and come up with the diagram first and then say, here are the two options. But then she was then able to use that. But you'll presume, yeah, she, as you say, when you went to the flat Earth, she was then sensitive to, oh, look, he's going to show. She probably, yeah, you get.
I don't think her or any other flat earther knows what a null hypothesis actually means.
No, they don't.
It's simply what will be the result if your hypothesis is not a factor.
They just know when you haven't got one. That's all. They say, "Oh, look, Gio hasn't got one of those. That means it must be. I can have a go at him for that."
It's a science word. Maybe I can use it.
Yes, exactly. Oh, she's a really sneaky little. I mean, that's why I don't tend to call women.
She's not sneaky. She's just dumb. The reason why you think she's sneaky is just that she doesn't understand what she's actually doing. So she ends up seeming sneaky just because of how incompetent she is.
I agree with you. It's a mixture of
I don't necessarily agree with you because
I think it's a mixture.
let's just contrast her to Debbie last time. But Betty, today's shot, in my opinion, was, first of all, she had a bigger vocabulary of everything than Debbie did last time. I don't think Betty is a stupid person. I think she's just ignorant on everything.
Yeah.
And the difference is?
Debbie last time was stupid.
Yeah.
Betty isn't.
There's a difference between stupid.
That's functionally equivalent.
Yeah, it might be functionally equivalent, but there's still two different characteristics. It means, in other words, you could fix Betty possibly if you educate. If Geo had, a couple of days with an educator, gave her the education of a 13-year-old to get to school, you might get somewhere with Betty. Though Debbie, it might have a problem.
You would fix both of them with a fucking bat.
No, hold on. I got told.
Yes, that's obviously a joke. I don't actually want to beat people up.
No, my favorite part of the hangout that I watched early on was when you were sitting there talking about the angular size of the sun, and she says, or you asked her about how the angular size changes, and she's like, well, it changes on some things and not on others. That's called special pleading.
No, it's called perspective.
What do you think about when she started talking about the 10 Commandments?
I missed that part, thank God.
Yeah, I missed that.
Yeah, well, first of all, she asked, she said she would base her beliefs on the 10 Commandments or the rules for being good.
Well, she broke them.
Yeah, my first reaction was, which set? There are actually
and she got
two.
confused by that.
And I think she didn't know the fact.
Yeah, this is where intelligent people are caused by religion to remain ignorant, willfully ignorant, but actually can be quite intelligent. So this could be a case here that religion is driving her to do this.
Right. So for those people who don't know, there are actually two passages in the Bible where it refers, or where there are 10 Commandments.
Yeah.
The first one is the one that the Bible doesn't refer to as the 10 Commandments, but it's the one that you usually see as the 10 Commandments.
And when Moses came back with that one, he actually broke. That's the one he breaks.
Yes. So what happens is Moses gets those 10 Commandments, and then God stops for a second and then continues through Exodus 21, 22, 23. Then Moses walks down the mountain, breaks the tables, goes back up the mountain.
Because he sees that people are breaking them and gets pissed.
Right, and then he gets a completely new set of 10 Commandments, which is the set that the Bible actually refers to.
Not entirely new.
Yeah,
there are some overlap, but one of the commandments in the new set he gets is like you're not allowed to boil a goat in its mother's milk.
Yes, you're not allowed to boil a baby goat in its mother's milk.
That is apparently so important that it had to be part of the 10 fucking most important rules.
Right, and the other one that is really weird is all firstborn children are mine. So that
kind of suggests human sacrifice.
Yeah,
you might want to add that apparently God says he'll repeat the exact same commandments.
Yeah.
There's only 2 or 3 of them that are actually the same. But they're not even identical. They're just similar.
And all the stuff in between is actually more disturbing. Like in Exodus 21, it's talking about how to enslave your fellow people.
Yes.
How well you can beat them, what to do with with people.
Like you can beat them. You can beat them for 2 days. You can beat your slave for 2 days.
No. If you beat them and they survive,
if they can get up, if they can walk after 2 days after you've beaten them, then everything's fine.
Exactly. Or how you, when somebody of your fellow people has a debt, he can become your slave for a limited
60 years or something.
But you can actually trick him to become your slave permanently by giving him a wife.
My favorite is the fact that you're not allowed to wear mixed fabrics.
Yes,
linen and random rule.
Was it linen and cotton? Is it linen and cotton? If you mix those two together, that's punishable by death.
Yep.
Yes.
Basically, the Exodus in the Bible is like the Netherlands and like the United Arab how's it called?
Emirates.
United Arab Emirates. Thanks. Have sex and get stoned.
I mean, a lot of the rules sound
people got that joke.
Someone who I got the joke. But a lot of the rules starts to sound like it's just like you had some guy who had power, and he just like Oh, now they're eating shellfish. I hate shellfish.
Well, it was all appropriate just for the time, wasn't it? It's like a tribe, a barbaric tribe, but living in a desert, and they came up with some rules that are completely inappropriate.
How many shellfish did they come upon walking in the fucking desert?
Well, some of them wandered in desert. Possibly they used to be outside on the coast, and then they walk it. But they mishmash between desert and coast and things. So it's definitely.
I was making a joke.
Oh, you little devil. Yeah, because of course the Exodus is all about them wandering around in a desert for 40 years. Goodness knows how they managed to do that. They must have covered everywhere. I will say, because that like the whole idea that they took 40 years to walk something that would take 2 weeks. Haha, look how stupid they are. That is not really an argument, because the reason why they had to they didn't wander around the desert to get from A to B. They did that because that was a punishment that they had to live as a nomadic people. Oh, did they? Okay.
Yeah. So it's a bit unfair.
Okay, and it's obviously they felt really annoyed by all this, and that's why they came up with all these outrageous rules for having to put up with all this living in a desert lark and being punished. They thought, okay, now we're going to.
They got food by striking a rock.
God. Oh God.
That's what manna is. That's where we get the word manna.
Oh, really?
I'm not sure why manna is always blue in games. It's white. The written description is that it's white.
Right.
Interesting. Isn't it usually green in games?
I think it's usually blue. Stamina is usually.
Mana is blue.
Oh yeah.
Health is red. Stamina is green, and mana is blue.
Right.
Doesn't mana translate directly to bread in Hebrew?
Translates to what?
Bread.
Yeah, it is some food stuff. It actually translates to.
Yeah, so shouldn't it be white?
I don't understand.
Well, yeah, it's white, and it's described as white in the actual text.
Unless they use wheat.
Talking about weed.
Or rye.
So that burning bush, though. Can you describe the leaves?
Well, it was most likely actually of like a volcano thing.
Yeah, probably. I know.
No, I get it, Gio. I got it.
Mana. So regarding Betty, any other comments? Elsa, you haven't said much.
I think he's like me. We haven't seen the hangout yet.
No, I've seen pretty much all of it, apart from the 15 minutes or so I was away. I actually literally watching porn to get rid of my headache.
Headache.
So instead of pounding one head, you're pounding the other.
Pretty much.
All right, dick jokes. No more dick jokes today. Sean just won it.
Damn you, Sean.
I win all of the jokes.
That kind of sounds like you're insulting his dick.
I just think it's funny that we've gone from having independent variable John to having independent variable Nathan, and then now independent variable Betty, and none of them understand their own talking points much.
Maybe it's like a brain parasite that jumps, and that's how you can that's how you can tell that someone is infected.
No, it's the congregation of stupid. They realized, like Nathan, Riley, Betty, that whole ilk realized they really weren't able to get anywhere with someone who was scientifically minded. And then they saw Quantum Eraser and were like, hey, he sounds like they do. It seems like he's getting somewhere. Let's copy him.
Independent variable John probably has had a raging fucking stiffy for the last 4 weeks, considering he's been able to have a platform again to spew his shtick that he started 2 years ago and that was shut down within a week because he didn't actually understand the things he says.
Yeah, I had an hour and a half long debate with him about a year and a half ago, and even the flat earthers thought they were embarrassed by his performance against them. I mean, they even voted against him in this thing. It was ridiculous. I mean, it was so easy. It was just stupid.
What?
I couldn't believe how easy it was.
Wait. Okay. I'm not sure how I can comprehend that level of stupid.
Yeah, I mean, yes, I mean, even the flat earthers felt that he was completely. I mean, there was a vote at the end on this thing, and they said they were criticising the points he was making for his flat Earth position, and I was able to undermine him. It was just amazing, and yet now he's come up with this crap, and he doesn't understand so many basic things about physics, how gases work, the atmosphere moving around the Earth. He Coriolis effect is an independent variable, and the fact he doesn't realise, for instance, in Geo's example of Polaris, I bet he would have claimed that was not an independent variable moving from the pole towards the equator, because he doesn't understand how independent variables work. He doesn't understand Foucault's pendulum. Changing the latitude is an independent variable, or other things that you can do, changing elevations and telescopes and a whole of things you can do to have independent variables.
Kind of, right. I mean, it's a reoccurring pattern in flat earthers that as soon as you show them that there's geometrical problems with the flat Earth, they will try to avoid the topic like the plague.
Yeah,
I would actually be kind of like, just out of like a weird morbid curiosity, I would be interested in seeing what there would be to you like giving them an exploratory study where you don't have a hypothesis, where you're just like looking to see what happens.
It'll be love. It comes down to love, microblogger.
Just for clarity, 2 years ago, every single flat earther on YouTube swore up and down the AE map was their model.
Yeah.
2 years ago.
Out it wasn't. For some
and
reason.
Now all of a sudden, because they can't get anything to work on it, it's not our model. We don't have a model. And it's because they've been debunked left, right, and center of everything.
Did you guys they've been reduced to just jacking off, just asking questions.
Yeah, in fact, a good example there, actually, Sean, was a couple of days ago. I was on Nathan's thing, and Riley, he was trying to explain the counter-rotating, the axis of the stars, counter-rotating on the axis, and he offered this map where he said he had two, sort of like a Chinook helicopter thing, where two revolving sets of stars. Oh, you were there, of course, of course. And then I realised afterwards he hadn't used an AE map. He'd used a bloody Mercator projection. So if you went north on his thing, he wouldn't have got to the North Pole. He has a Mercator map he was suggesting was the flat Earth model on his thing. Oh, God. So he sneaked that in because he was trying to get his counter-rotating bloody things to fit in, which wouldn't work at all, of course, on an AE map. So I think, they do regard the AE map now as a bit dispensable.
Well, I pretty well debunked it working on his little Mercator map, too.
Yeah, we did. I mean, but I hadn't realised that you can then say, hold on, you can't be using this map, Riley, because if you're going north up here, you're not going to hit the North Pole, are you? According to your map, because that's in the centre of the top of your Mercator map. There's no point on this Mercator map where the North Pole is on the one you were suggesting, because of course the North Pole all gets super expanded anyway. But yes, I didn't realise he'd sneak that in, and obviously because you can't stick in that AE. If you try to use an AE map to do what he was doing. One other point I actually think about that counter thing was the void we're having. Of course, if you did have, I think I mentioned at the time, but if you did have stars out there, of course they would be overlapping with one another, which was the other point I meant to make at that hangout, and therefore you'd have lots of stars actually overlapping with one another that are going in opposite directions. Oh, Jesus. God, that was bad.
The more you think about it, the dumber it gets.
Yeah. I think it's right. Whenever, I mean, for instance, when Riley offered that thing, people sort of let him get away with it. But when you suddenly try and think, well, okay, what are the consequences of doing these sorts of things? And you suddenly realise, hold on, this has got to overlap with that. It's got to go in the opposite direction to this. Also, things like the you don't see circles is the other classic thing, of course. You don't see stars when you look at east or west in his little demonstration. Yeah. And also we ought to bear in mind that all this rotating stars they've got is on an axis coming out of the North Pole. Well, of course, if you're away from the North Pole, these don't look like circles. They look like ellipses. They're going away from like the sun, just like the sun, of course. They're going away, should be getting smaller, but not only they're getting bigger and smaller, but they're also moving in an ellipse, which is not what we see when we stare at the stars. It's all going around in a bloody circle.
Did you guys see Wolfie's video he released today?
I haven't seen it yet.
Yeah,
I haven't seen it yet.
It's pretty good. It's about the AE map and where the sun is.
Oh, yeah, with all the arrows on it. Yeah, that was awesome.
Yeah.
I'll have a look at that.
Yeah, it literally takes one moment in time across one entire meridian and shows where the sun is from all locations and where they all point to.
Oh, nice.
And it does it through different times of the year, and it's really amazing.
And then it morphs into a globe.
Yeah. So whoever did that,
Yeah,
well
pretty-
done, sir.
Yes, well done.
Sly's got competition.
Maybe it was Sly. Uh-huh.
So I thought it was Soundless video. Sorry, it was
No, Wolfie's.
Wolfie. Sorry, that was it. Wolfie. Right. Okay. Right. Yeah. Yeah, because I thought also I got Cortus and I was prodding Cortus about doing a model showing what the day, the fact that if you just draw on a flat on the AE map what's illuminated and at what time of the year, just simply saying, hold on, so because you in the summer, when it's summer down in the Antarctica, you get this sort of strange strip of light around the rim of the AE map in the summer of the Antarctica, and saying, well, how do you explain where can the sun be to account for this? And I got caught to do an animation. Well, he didn't know it anyway, but I was suggesting a modification to it, and so he put it in various ways, and you can go marvelous showing you the seasons on Cortus's YouTube channel. He's got a couple of videos, and this is the last one I think, and it just shows how in the seasons where the shape has to change, and there's no way any object floating above a map thing can generate this shape. It's that in itself is fantastic.
Well, as Cool Hard Logic says, it's a shape-shifting lampshade.
Yes, yes. Which doesn't. It mustn't get bigger and smaller, of course. Somehow. I mean, sunsets, for God's sake, sunsets. Jesus Christ. Where does that sun go? Oh,
it's all about perspective and
yes.
optics and
it's perspective. Yeah. Lensing or something. Oh my God.
Atmospheric lensing of the curvilinear aspect.
I couldn't believe she actually said this, that the angles will be the same on a flat Earth. Oh my God!
And then when you try to actually show her, like saying, okay, well, let's put them in and actually see what the angles would be. We can literally test that. She basically just kept repeating it, and then basically got to the she basically made the point that data doesn't matter, like that. Being able to show it doesn't matter. But
once you wanted to show her the difference between the two, Geo, she wanted fuck all to do with it, because I think she knew it would be wrong.
Of course she did. And by the way, Rumpus, off topic, but that was a very weak attempt at a Beeloo voice.
Sorry. Yes. I'm not, Sean, I can't compete with you. You go like you did that so well.
All right. Now I just have to do this in the direction of the people in the Hangout. So Halsoy, do your best Beeloo voice.
Okay, let me get in the mood here.
Get into character. Remember, you're in a bush where your feet are wet.
Beeloo loves you.
No,
that was pretty good.
All right, Hillel.
Wait, is Hill's mic working yet?
Seems not.
No idea. If he isn't, he's excused. So Jared.
Beeloo love you.
That was good. Micro.
I have no idea what you're talking about.
Oh, you're roboting. I think you have to go.
I don't know what you're talking about. I have no idea what this is.
Micro, there's something wrong with your microphone.
Yeah, you're breaking up.
Yeah. You have that usual bug, that was his
Beeloo. That was his Beeloo. That was his.
To be fair, Jared, you went way Elmo with that voice.
All right, so Soundly.
I don't have anything.
Come on.
Make the effort.
Give it a try.
Make the effort of what?
The Beeloo voice.
The Earth is flat. The Earth is flat. You just have to listen to me because I know everything. I'm an all-wise wizard from the planet Nibiru.
That's not bad.
I think that's good, actually.
All right.
How do I sound now?
Much better. So, Micro, let's start with you then.
I have no idea what this is.
So, Beeloo is a fake alien that talks outside a bush and has glowing eyes.
What do you mean fake?
Okay.
It's from Convict's Earth, man. You gotta go catch up.
I don't have to do anything.
You're telling me that a Portuguese-speaking, bushwhacking alien pedo bear is fake? Not actually real?
That sounds pretty real to me.
Oh, Sean, do you remember the picture that I sent you of Beeloo? You know, a bush with glowing eyes?
Yeah.
Do you think that's share, Berthy?
Let me look at it again.
The most amazing thing about that video was that the Earth was flat, not that they were speaking to an alien in a bush.
Yeah, exactly.
Rumpus, got to unmute his voice.
Oh, I've got to do it, have I now? Oh, God.
Yeah, sure.
Oh, bugger.
To be fair, an alien landing here and revealing information is actually plausible.
But from a bush, though.
Yeah, but that's
Well,
still
you don't know what alien culture is like.
And I'll give you that. Let's say that there are some alien species that decides to land here and give us information. Are they going to meet up with a bunch of random Brazilian guys in a bush? I don't think so.
Well, you are
So, Rumpus, I'm still waiting. Come on.
Oh, God. I think I'll drop my keys here. Can someone help me get my spaceship craft keys, please? I'll tell you.
Go and do a bunch of tests instead of looking at this picture that I took from
Finally,
over.
I think now it's my turn. Hello, I'm Bilo, and the reason my voice is so high is because I'm breathing helium, which makes no sense. It's not gas. Hello.
No. It's got to be between Sean and Soundly, I think.
Yes.
I mean, all we're doing is doing really, really high voices.
Oh, right. Wow. That's a late charge from Micro.
Why are we doing this? This is fucking weird.
Because Vito knows everybody.
Hey, no fair. His wind's got a drag off of his helium tank.
Yeah, that was pretty good. Oh, dear. Oh.
I have no idea what I'm doing. I can just do a high-pitched voice.
Yeah, so that was very good. I think that's the point, though. It's what someone thought, like you've done. Thought, I'll put on a stupid alien voice, and everybody's got the same one. So
I'm going to share this now. So apparently Hillel Finder edited the Betty Van Velzen page in the Great Debate Community Wiki. Betty versus Geo. Betty, to the surprise of literally no one, was no less of an idiot in the waning months of 2018. For over 2 hours on the 6th of April, Betty had a long conversation with Geo about the nature of scientific models, evidence, and the apparently incomprehensible concept of an independent variable. Things did not go well at all, even a little bit, slightly. I, as a person who values your health and well-being, cannot recommend watching it without adequate mental and physical protection. This includes, but certainly is not limited to, a small nuclear bunker, 33 pairs of extra-strength oven mitts, German absinthe, Russian vodka, Scottish scotch, American Bud Light, and 666 grams of Catholic holy water, a Faraday cage, subscription to Masochist's monthly magazine, a large butcher knife, an extra large condom, a nearby waterproof receptacle, Obamacare, the Bible, King James Version recommended, more than 3 layers of straitjackets, a phone with a suicide hotline on speed dial, ending. Once this ultimate level of protection has been achieved, you might be safe watching this hangout. Maybe.
That's very good, Hillel. Yeah, very good. Very well written. Well written.
That's pretty good, yeah.
Oh God, she was being devious as well, though. She was a naughty little quantum eraser style of behaviour. Oh, geez, that annoyed me quite a lot. So Hillel's right. You were getting you need to calm down after watching that. Well, I'm still not.
I think she actually might be the most annoying person you have. For me, she was the most annoying. Most anger-inducing person you've talked to.
Micro, I think Debbie last time was worse because she interrupted me literally in every sentence.
For talking to, I completely agree. I think Debbie would probably be worse. But in the audience, the things she said and the smugness that Betty had, she pissed me off.
Yeah, she was smug. Yeah, absolutely right. She was
you haven't seen many Nathan hangouts, have you?
I was gonna say, if you want my evaluation of Betty from what I've seen tonight, she went to the school of Nathan Oakley as far as just talking over and dodging. At least when it comes to people like Riley, when you have him cornered, he will just make up random bullshit to try to talk his way out of it. He won't avoid a topic most of the time, but he will just make up random, complete and utter bullshit to get out of his story. But Betty, she just dodged the whole night.
I stick by my claim that I made in text chat, saying that her IQ is probably too low for her to be legally allowed into the armed forces.
I don't think she's that stupid, Halsoy.
Hey,
Yes,
well,
there is a
Normally I
bit.
accuse him of being stupid, but in this case, I don't think she is.
Hold on, Rumpus. Here in America, the ASVAB has actually got a rather large mathematical section. So yeah, she would fail miserably.
So her job is to set the nuke button for 4 hours, but she blew it up in 4 seconds.
And she targeted herself.
Yeah, people should not have access to that then.
Yeah, I think you made a good point about the smugness, Micro. She would occasionally she would giggle at Geo when he was saying something really quite simple, saying, "Oh, you believe that, or you haven't presented me with an independent variable." In other words, she would giggle at him as not having done something he'd done about 10 seconds earlier, and I find that really infuriating.
Well, no, I thought it was funny when she started laughing when she asked what the null hypothesis was as far as the Edfus effect was, and that would be that in Geo described it, the Edfus effect would show that there was no correlation between going east or west.
Yeah.
Really the null hypothesis would be that
like she was smarter than she actually was. That's why she came off smug. I don't think she actually she might not have intended to actually come up off a smug. I think it's just a consequence of like her thinking she's way smarter than
Dunning-Kruger.
Yes, that's the word I was looking for.
Comment to the side chat. SciFatK85 apparently says that Spurs got caught on Discord coaching Debbie in how to troll more effectively, and she's much worse now. Is that even possible? What the heck?
Well, I think there is. She did employ lots of really devious strategies, so I keep on calling her devious. She kept on trying to pick at little things of you, like you offering the radius or presuming the Earth, even though she was hoping you wouldn't come back with, but that's a presumption I'm allowed to make in testing this model. So she had lots of quantum eraser style devious little prods at you and about not having the null hypothesis and things like that. Lots of really devious little things anybody who's being honest in their engagement wouldn't be doing.
Well, here's the thing that they all fail to realize. Every single flat earther fails to account for this. Yes, we make assumptions when we're testing a hypothesis. The problem comes in when the actual experiment matches the hypothesis going under the assumption of whatever we assume.
And that's what the hypothesis is. You come up with these things. Your hypothesis makes some predictions, and your experiment tests whether those predictions come to bear. That's the whole procedure.
So if you make assumptions and you test the hypothesis that those assumptions require, and reality matches, those assumptions are deemed correct.
Exactly.
Right.
They're valid. Halso's trying to say something to me.
Yeah, I was going to say, like, what you attribute to deviousness, you got to keep in mind, this is coming from the school of independent variable John.
Yes.
That 2 years ago, the only reason he even got past a single hangout was because, it's essentially like the Sci-10 effect. He introduced terms to people that were not used to hearing those terms in certain contexts. So people were a bit stumped, like, what does this even mean?
Yeah.
That's the only reason he got past the first hangout. And then he got laughed right out of court as soon as people actually picked up on what the fuck he was talking about. And the same thing. So what you're attributing to deviousness is simply just Betty trying to use the same tactics. She's trying to introduce terms that she's used to dealing with, don't know what are. So when she's getting a response, she assumes that the response you give is incorrect because she's not used to talking with people that actually know the terms.
I completely agree with you, but I think she was also being deliberately devious as well as trying to use tricks with new terminology, and indeed wasn't confused because when Geo did say this is the independent variable, she didn't accept that. It didn't seem to go into her brain. This is why I said that Geo should then said, repeat to me, back to me, what I said the independent variable was, Betty. Goddamn thing.
Independent variable John and quantum eraser are the same person, right?
Correct.
Yes.
Oh, okay.
I just call him independent variable John simply because the only thing he did, like there's a hangout about 2 years or so back where quite literally the only thing he did for like half an hour was say, what's your independent variable? Yeah. What's your independent variable? What's your dependent variable? What's your independent variable? What is it? What's your independent variable? What's your null hypothesis? What's the independent variable? Yeah. That's all he did.
Yeah, he switched between null hypothesis as well. Yeah, those are the two he does. Yeah. Yeah, but I think she wasn't. But Halso, you're not claiming that she was genuinely engaging, just simply trying to use terms. She was being disingenuous the way she wasn't trying to get the answer of what the independent variable was from G, or at least if she was, she wasn't listening to the answer. She was definitely being devious as well as using the trick of using new terminology, which itself is a devious thing to do.
I'm not entirely sure she was actually being devious on purpose. I think she literally just used the strategy she had seen.
Yes, I mean
without actually
it's a mixture, but there was definitely a devious element to it.
I refer to the Anthony Roakley show.
Yeah. He does that all the time. I mean, his classic thing is that
where's the curvature?
Or
where's the scientific
method? What's the scientific method? And of course, he then says amazingly this. And I still haven't had a chance to accost him about this. He says, "What's the scientific method? Why haven't you included a independent variable of null hypothesis?" But of course, he then cites, and then people ask him, "Well, where are you getting this idea of what the scientific method is?" And he then refers to the quantum eraser thing, who then refers to a document, and in there is no reference to a null hypothesis or an independent variable. So the actual thing they're basing this all on is actually not there. But Nathan doesn't know this at the moment. And I've still yet to be able to accost him about it.
Well, did you hear him define the scientific method? I think it was day 2 after independent variable John was on his hangout. He said that the scientific method is the scientific body, or the body of scientific knowledge. That's what the scientific method is.
Yes, he equated those two, which was absolutely
fuck.
I did correct him about that. I said no. In fact, I actually corrected him several times. They said you're not getting the English correct. You're using false equivalence here. The scientific body uses the scientific method. And he couldn't understand this. It was almost
the scientific body of evidence has been gained using the method.
Yes,
he thinks they're the one and the same.
Exactly. He equated them. He said science is the scientific method. No, it isn't. Science uses the scientific method. As well as peer review, because of course the scientific sort of what I call the scientific process then uses the people use scientific method to get their experiments, then use the peer review process. I would argue is a scientific method.
There are when you say science, we actually it kind of has 4 different meanings. There's science as in the scientific method. Then there's science as in the science, the social aspect of it. Then there is the body of evidence, what science says, and then there's the institution, as in peer review and academic institutions. So that there are kind of four different, it has 4 different meanings.
Probably more, actually. You could probably slip in some more.
Yeah, there's probably more out there, but that's just the 4 I could
I suppose when I think of science, I think of the body of knowledge and the authority of science. Saying, what does science have to say about, I don't know, the sun or something?
And that's usually what's meant.
The first thing you think about when you're talking about science is the compilation of knowledge that has been gained using the scientific method.
Exactly. Yeah, that's how I would go. There's a first.
I'm also fairly convinced that most of these people think that statisticism is a better way than empiricism.
Probably.
To discover truths about reality.
I wouldn't surprise me, honestly.
I mean, it's pretty evident in the way they some of the questions they pose, like, did you touch it? Were you there? Right, that kind of thing. Because
you weren't there, man.
Yeah.
Were you there?
This is what I'm asking about atoms. This is what I say. Do you believe in China? This is my classic response. This is, okay, do you believe in China then? And if not, if you don't believe in China because you haven't been there, you can't claim. Similarly with atoms. Do you believe in atoms? If you haven't seen them, you haven't touched them or identified them as a single individual atom, then do you believe in that?
Yeah, I was waiting for that.
AFM.
Waiting for that. Geo has he's just single atoms.
Yes, for my bachelor's thesis, I was working with an atomic force microscope, which you can actually use to see individual atoms.
Yeah, but you haven't touched it, though, have you? You haven't been there, though, Geo.
Well, I've touched the cantilever of it, and I fucked it up, which meant I had to repair it.
That's not the same.
We've all touched single atoms.
That's what I'm saying.
We do it all the time.
No, I mean the microscope, the tip, the measuring, the scanning tip of the microscope, accidentally.
Technically, Micro, that's incorrect. You have never touched an atom before.
Yeah, I was gonna say, because as far as I know, there's some I don't know what they are, but there's some forces on the micro scale So you're not actually
pretty much
physically in touch with an electron.
If you want to say that, they have never actually physically collided. I've never physically collided because I'm unable to overcome the repulsion between the electrons.
Right, it's
very bad.
But when you two electron shells, that's what's happening. The electron shells actually can't touch each other under normal circumstances.
So what you're saying
bad when they do.
Hoverboards are real.
Technically, yes.
Yeah.
You are hovering. Yeah, you're hovering a little bit. Yes.
Except I have actually touched an atom because when I was in my mom's uterus, I was connected to her with chemical bonds, and the placenta was technically part of me. It was made out of my cells. It was a temporary organ.
All of the atoms never touch.
Yeah, exactly. The atoms don't touch.
Well, here's what you have to do, Micro, to actually get touched by an atom. So you go to a big particle accelerator, for example, the LHC down in the CERN complex.
Hold on, what about alpha radiation?
Yeah, whatever. Listen to me. And then what you do is they actually have a lead block to catch particle blocks particles that are accelerated and that need to get out of the ring. Then you stand in front of that. I think that will pretty much allow you to touch an atom.
I can just find an alpha source.
And as I said, it's when atoms touch that bad things happen.
Yeah, I was gonna say, like, so the particles, they actually accelerate. What do we know the interaction it would have on something organic, or if any at all?
It would just rip it apart.
So this the LHC has 80,000 was it 80,000 tons? No, it can't be 80,000. I think it was 80 tons. 80 tons lead block as a brake for particles that need to get out of the ring. And those fuckers, this lead block actually heats up quite a bit when it gets in contact with a particle ray. I think, let me try to find some pictures. So
yeah, I thought that you could stick your hand through the ray at the CERN, and it would just go through it. I didn't think you would suffer too much.
So here's the thing. I used an electron microscope for an experiment once, and even that, and that's just electrons at a relatively low energy. Even that causes damage to metal surfaces. So
I'm pretty sure if you were to put your hands through the beam at the Large Hadron Collider, that you would get damaged by it.
Yeah, I think
a little bit, yeah.
Less than you would think, I think.
Possibly. But the fact still remains that alpha particle
your question. Why don't you go ahead and form your hypothesis?
The fact still remains that I have been hit by alpha particles, which would have touched directly on some of my atoms. So I have touched atoms. Well, okay, I've touched ions, but that's basically the same thing.
Particles. We're talking ionizing at that point, right?
Yes.
Yes, alpha particles are the ionizing. I work with them all the time at work. Yay, X-ray machines.
But that's X-rays, not alpha particles.
No, it is an ionizing. It does the way
ionizing. But we were talking about alpha radiation, not X-rays.
No, that's the thing. Mine, it actually is an alpha particle generator to get the.
I use it to get the X-rays. Oh yeah, fair enough.
Right. Yeah, I think that's strictly reserved for luggage.
It is, but I work right next to it, and sometimes have to crawl through it, and I have to wear a dosimeter that gets checked quarterly.
Oh, did you see the dude that actually fell asleep on the airport conveyor belt and actually went through one of those stupid X-rays?
Yes, he is the reason why we lock the ladders to the best.
So
wait, what? Wait, I didn't hear the story. What?
Yeah, some dude apparently fell asleep waiting on his luggage from his craft on the actual conveyor belt, and he actually went through the X-ray machine for luggage.
So there's something I want to talk about. There's a guy called Anatoly Bulgotsky, born 25th of June 1942, and he is a Russian scientist who was struck by a particle accelerator in 1978. Let me just talk about. So there's a Wikipedia article. I'm just gonna read it.
Let's just get this straight out. Did he die in 1978?
No, he's still alive.
Okay.
Yeah,
Okay.
So let me describe what happened. So accident. As the researcher at the Institute of High Energy Physics in Rodvino, Burgoski worked with the largest Soviet particle accelerator, the U-70 synchrotron. On July 13th, 1978, Burgoski was checking a malfunctioning piece of equipment when the safety mechanisms failed. Burgoski was leaning over the equipment and he really stuck his head in the path of a 76 giga-electron-volt proton beam. Reportedly, he saw a flash, quote, brighter than 1,000 suns, but did not feel any pain. Aftermath. The left half of Burgoski's face swelled up beyond recognition and over the next several days started peeling off, revealing the path that the proton beam, moving near the speed of light, had burned through parts of his face, his bone, and the brain tissue underneath. As it was believed that he had received far in excess of a fatal dose of radiation, Burgoski was taken to a clinic in Moscow where the doctors could observe his suspected demise. However, Burgoski survived and even completed his PhD. There was virtually no damage to his intellectual capacity, but the fatigue of mental work increased markedly. Burgoski completely lost hearing in the left ear, save a moderate case of tinnitus. The left half of his face was paralyzed due to the destruction of nerves. He was able to function well, except for the fact that he had occasional complex partial seizures and rare tonic-clonic seizures. Burgoski continued to work in science and held the post of coordinator of physics experiments. Because of the Soviet Union's policy of maintaining secrecy on nuclear power-related issues, Burgoski did not speak out about the accident for over a decade. He continued going to the Moscow radiation clinic twice a year for examinations and to meet with other nuclear accident victims. Like, what the fuck, how many nuclear accident victims are there in 1978? He was described as a poster boy for Soviet and Russian radiation medicine. In 1996, he applied unsuccessfully for disabled status to receive free epilepsy medication. Burgoski showed interest in making himself available for study to Western researchers, but could not afford to leave Rodvino. Burgoski is married to Verena Nikolavina, and they have a son, Peter.
Here you go, Geo, since we brought it up. The guy on the airport conveyor belt.
Oh, this is great.
Yeah, it's actually, there is a step during the startup procedure of all of my scanners that prior to it turning on the high voltage power supply to start exciting the beryllium to generate the particles, it runs the main conveyor and exit conveyor belt to clear out anything, because this one happened in Honolulu. There were some homeless people asleep inside the middle of the scanners.
Wait a second. So beryllium is exited. Are you sure? Isn't it tungsten? And then beryllium is the window through which the X-rays can pass.
No, the actual filament, the way our tube is manufactured, it has high voltage going straight to a beryllium filament that is oil cooled.
Okay.
And it's a...
Yeah, I thought they were usually using tungsten as the target for the Bremsstrahlung. And yes, Bremsstrahlung is actually a word.
It might be a...
Of course it's a word.
I can't remember. It could be a tungsten-beryllium combination filament, but it's a single piece, and the beryllium especially is hazardous, so we don't crack them open at all.
Yes, it's understandable. Beryllium is actually the most toxic element that is not radioactive.
Yeah, stop presenting me.
Don't come in contact with that shit. You would regret it.
But what about the beryllium sphere?
I would contest that nitrogen, carbon, and oxygen and hydrogen in the right combination is worse.
But Gio, what if we need a beryllium?
But I said element. I did not say
element.
But Gio, what if we need a beryllium sphere?
Oh God. There is not another beryllium sphere aboard.
At least you got the reference.
Of course I get the reference. It's actually it's the 6th best Star Trek movie.
Oh my God.
The 6th best, like right off the top of his head.
The 6th best Star Trek.
Have you met Gio?
2, 4, 6, 8, and
who do we appreciate? Gio.
9 are better. No, not 9. Wait. 2, 4, 6, 8, and 3. There we go.
Great, he's turned into a number station.
Not even chat got the joke. Oh my god.
So for the chat, the movie is called
Galaxy Quest.
Galaxy Quest. Yes, it's a parody of Star Trek with Tim Allen, Sigourney Weaver,
a couple
and
other people.
Rickman.
Yeah,
And the
Alan
guy who
Rickman
played Monkowski called Danny Shalhoub.
Yeah, Tony Shalhoub.
Tony Shalhoub. There we go. So it's
then-
actually worth watching. The best scene is when they try to beam up that pig lizard thing, and it turns out inside out.
It turned inside out, and then it exploded.
And then it exploded. Now, there's actually a cutting mistake in that scene. You can actually see the hand of the guy who is controlling the puppet of the pig lizard thing for a second or two.
So yeah, if you haven't ever seen the movie, you got to see it. It's absolutely hilarious.
Yeah. Pretty much, Sigourney Weaver's only job is to repeat what the computer says.
Well, I'm gonna head off.
Yes, I was about to end this anyway.
Okay, then I'll stay and let you end it.
So we're gonna do this in the good old rhetoric fashion. So Hellsoy, say what you gotta say and go out or leave. I don't care. I'll stay.
What?
He was distracted. He was still pounding his other head.
Oh.
All right, I need more beer to get this picture out of my head, my primary head.
At least it's a small picture.
Remember, Sean, I have an atomic force microscope.
This is true. So it'll look what, 2 pixels across?
Well, you do have to apply force to it.
So again, Hellsoy, say what you gotta say and leave or stay. Do as you please. But don't please yourself. That would be weird.
What?
Mars attacks.
Oh,
I didn't. Yeah. All right. Yeah, that was pretty obvious.
Uber nerd right here.
Okay, so Hitler didn't say anything, so he has no right to say anything. Jared,
What's the question?
say what you gotta say and either stay or leave.
Geo, like I said in the live chat, and I think you missed it, you owe me for a new desk, motherfucker. My head went through it at least 3 times.
Before the hangout, I specifically stated that you would need at least a pair of oven gloves, and I wouldn't pay for any damages that would be caused by this hangout.
Too bad. You still owe me.
Let me see. Again, thanks for joining, Jared. Micro.
what's the independent variable here? In me leaving.
Time.
Oh, fuck.
I have the hypothesis that you will. Oh, he's gone. Okay, hypothesis confirmed. Sean.
What's the null hypothesis of you ending this hangout?
I can't brain today anymore. See you. Soundly.
Yeah, just be on the lookout for my new channel called Belu the Great.
Oh no!
soon.
Did you seriously do this?
No, but I might now just because I know it's going to aggravate you.
Oh, God.
Bye.
All right, Rumpy.
What was the question? I've been away. What was the question?
So this is something that we usually do to end hangouts. Say what you gotta say and leave.
Flat earthers are allergic to maths.
Are you stuttering again? Are you stuttering again, Rumble?
I am. I'm on that one. My brain had to think on that one. Yeah.
Okay. Bye. And for everybody who's still with me for some reason, thank you everybody for watching this and look forward to the next one. I don't have anything scheduled right now, which is unfortunate. Still trying to get Renty to talk to me because he said he would regarding chemtrails, which would be pretty weird, but I want to know his opinion about this. So thanks again for watching and see you for the next time. Bye, guys.